Okay, welcome everybody. I'm just going to go through some logistical details before we get started. On the screen right now, you'll see the agenda. We have two built-in breaks today. And yeah, we'll go to about 11:45 and we'll stay a little later if there's any questions, but the program will end. If you have questions for speakers, please type them into the Q&A. That should be at the bottom. You can see in the sample of your Zoom ribbon bar. Make sure to type the name of the speaker and then your question so we know exactly who it's directed to. So Craig and then the question. Don't ask your questions into the chat. Please put them in the Q&A. We want to keep track. Use chat for comments and discussion. Make sure you put the drop down to all panelists and attendees if you want everyone to see what you've posted in chat. If you leave it at all panelists, only the speakers will be able to see what you've posted. For continuing education credits today, there is no DPR, so there's no private applicator credits, there are no PCA credits, none of that. The only credits we have are Coalition for Urban Rural Environmental Stewardship, the nitrogen credits, and we have Certified Crop Advisor. For the CURS credit, if you want those credits, you need to email ANR program support with your information, and we'll get that taken care of you. For the Certified Crop Advisor, at the end of the day, 11:45, there will be a QR code that goes up on the screen. You can scan it with the app. And if you don't have the app, you can email ANR program support, we'll add you in. And with that, I'm gonna stop my share and let Craig get going while Doug introduces him.
Hello, everyone, and welcome to today's session. My name is Doug Amaral, and I'm the Farm Advisor for Kings and Tulare counties, and I will be the session moderator. And now I would like to introduce our first presenter, Craig Carlson, UC Cooperative Extension Advisor for Kern County, and he will be talking about design of efficient pistachio orchard. Thanks, Craig, and you can start whenever you're ready.
Thank you, Doug. It's a pleasure to be here. What I'm going to be talking about today is design of efficient pistachio orchards. Again, my name is Craig Carlson. I'm the Citrus and Pistachio Farm Advisor in Kern County. And there's been considerable input in this presentation from Carl Fanucchi, a pistachio consultant here in the San Joaquin Valley.
Craig,
yes?
I just, perfect.
Good, thank you. I sort of given the verbal explanation for this, so we'll continue on with this. So there are some pre-planting issues to investigate before designing the orchard. And some of these topics will be discussed in more detail in other presentations, but I thought it might be good just to make a short list here. And some of the things that we want to look at before we decide to design an orchard, we want to make sure the farm has a suitable climate. We have enough heat units, low summer and fall rainfall, sufficient chilling, hopefully not too many late spring frosts. Do we have suitable soils? Do we have sufficient water available and of sufficient quality? We also wanted to think about things like how long will it take to receive trees from the nursery? Sometimes it can take up to 2 years to get rootstocks, at least it has in the past. And we need to make decisions on which rootstock and scion we need to choose. Something else, does the farm have power for irrigation pumps? Sometimes they can take a considerable amount of time before PGE or Cal Edison can get power to where you want to put your pump. You want to know where you're going to get the money to farm for at least 5 or 6 years, because you're not going to be making any money probably for 5 or 6 years. You decide who will farm them. Is it you? Are you getting elderly, or is it a son-in-law that's dependable? These are all questions that need to be looked at, especially if you're going to produce something, you want to know where to sell it, and want to know where is the process, or how far is it? Am I going to have to move these nuts once we harvest them after I harvest them? How long is it going to take to get the nuts to the processor? We have to do that fairly quickly with pistachio, otherwise that hull will start drying on the shell. So again, the major thing I'm going to be talking about today is orchard design considerations, and we're going to be talking mostly about tree density, tree design, pollinizer placement, and orchard floor management systems. So the well-designed orchard should create a farm that ensures the earliest economic return per acre. We want to get the maximum production per acre at tree maturity. and we probably want the least management costs. Now, some of these things are mutually exclusive, but we'll go through some of these issues. So first, the leaf canopy is what catches the energy from the sun to produce nuts. We think about fertilizers and whatnot, but really what the tree really feeds on is the energy it produces from the sun. So the more energy that we can catch, the more nuts we're probably going to have to harvest. So I think a question we want to ask is, how long will it take an orchard to achieve full leaf canopy and still leave room for machinery access to shake and catch the nuts? And the question, how many tree trunks do we need to hold up a full orchard leaf canopy at maturity? So we're really thinking more in terms of leaf canopy than we are trees. Now, if you plant your trees too close, the trees eventually crowd together, shading the lower tree canopy. And you usually end up with the nuts being borne really high up in the tree. And we usually get restricted flow of air through the orchard. And the closer the tree planting, pruning costs tend to increase because we got to maintain equipment access to the orchard, and we have to maintain tree isolation for shaking. What we really want to try to avoid is, for example, shaking this tree. And if the branches intertwine with the two neighbors, then we're shaking those trees, and those nuts aren't getting caught. They're falling on the ground. So you want to avoid that. And if the trees are too close, you probably paid for too many rootstocks. You budded and trained too many trees, and you now have to prune too many trees. So in general, trees should be at least 12 feet apart, which is really too close, but that tends to be sort of the length of the shaker if you're shaking the center tree. So that's sort of a minimum distance between trees without doing something dramatic to the shaker. Now, if your trees are too far apart, your potential yield per acre may be permanently reduced or delayed for many years. If trees are too far apart and grow too large, the nuts will fall outside of the catching frame at harvest. And another question is, how big a trunk circumference can we shake efficiently? In general, if we have the trees close together, they tend to, in some ways, sort of reduce their growth, or at least slow their growth. So there's probably a happy medium of where the trees are that prevents the trees from growing so out of size that we can't shake them. We have trees now that are so big, have been around so long, that we tend to shake the shaker rather than the trees when we try to shake them. So here's our decision. So which option will I base my initial tree density? If it's a high density orchard, you're going to get earlier economic returns. You're going to make that canopy cover the ground surface quicker. But in the long run, the trees may end up too close for easy canopy management. And they may end up too far apart to thin out the center tree if you've planted them too closely. So the other option is a low density orchard. And the problem with a low density orchard is a longer wait for economic returns, which can be critical because a lot of times people owe a lot of money to the bank and they like to see a lot of money coming back as quick as they can. But if you do have a low density orchard, that is, the trees are further apart, you get better airflow through the orchard, and you have to buy fewer trees, you have to train fewer trees, prune fewer trees, and shake fewer trees. So let's talk about the actual spacing. Pistachio harvesting equipment is large. So we want to space the rows of trees 20 feet or so apart. You can imagine, like from this picture here, as you see, these trees are still fairly young trees, but we're also already see how big this equipment is. So we got to have the rows further enough apart to get this big shaking equipment in and whatnot. A possible design of the tree is a square design. This particular one, where we have the trees 20 feet by 20 feet, there's 109 trees per acre. We don't see this type of square planting very often in pistachios, and I really don't think I'd plant pistachios at a maximum more than 20 feet by 20 feet. That's 20 feet between the rows, 20 feet between the trees. If you have really good ground, good water, you're a good grower, this still may be practical for some of our larger varieties. Spacing the trees closer together in the row may pay off where the trees that grow slower due to hard pans, high salt, for example, excessively high boron, or for other reasons. So we want to leave ourselves open to our spacing decisions. Trees in poor growing environments will take longer to provide full canopy leaf cover, so yield will benefit by higher tree numbers for a longer period of time. For example, the variety Golden Hills appears to be a smaller tree and can be spaced closer together down the tree row than, for example, Kerman. So we have two issues. If we have poor soils, we can probably put the trees closer together because they can take a long time to grow with high salt water and high salt soil. And a variety like Golden Hills, just because it has more upright growth, may be amenable to more closer spacing. The rectangular planting is what we see mostly in the pistachio industry. And commonly we still keep the 20 feet between rows or 19 feet between rows to allow for our big equipment. But we usually have the trees in the tree row somewhere around 17, 18 feet apart. So at this particular spacing, 20 by 18, we have 121 trees per acre. One thing I like to mention too is pruning gets more expensive, the cost of pruning, the labor and whatnot. If the trees are at least 17 feet apart, usually you can still do mechanical cross hedging. And that can often reduce the amount of manual pruning you need to do. And it may be particularly advantageous for organic growers with square or rectangular plantings to leave enough room between trees in the row to cross cultivate for weed control. Controlling weeds is always a big issue in organic blogs. And if you leave enough space for cross cultivation, you probably leave enough space for cross hedging. Obviously, if you plan to cross cultivate or eventually cross hedge the orchard, trees should not be planted on a berm. Here's another design that's been used in the past, the offset square design. In this design, we have trees in a row and we sort of offset the next row. So this tree will actually be in between its opposite in the neighboring row. There may be some advantages to light interception for this, but it does make cross hedging difficult. There's also something called a hexagonal planting. In this instance, the trees are all equal distance from each other in every direction. So 23 by 20. This is not the case with the offset design, where you see this this tree is actually 22.4 feet from this one. So these are small differences we're talking about. And I don't know anyone that does a hexagonal planting. Theoretically, with trees spaced like this, it might be optimal for light interception. But again, I think it's difficult to do in the orchard. So the number of trees per acre at different rectangular plantings, and I've just put some of them up here. You can actually calculate it using this formula. You divide your row spacing and tree spacing into 43,560. You're going to get your trees per acre. Again, this 19 by 15, 20 by 15, this would probably be more applicable to areas with poor soils, poor water, where the trees are going to grow slowly. And these wider spacings where we have excellent soils in general, where we tend to think the leaf canopy will fill in fairly quickly. In pistachio, male and female flowers are born on different cultivars. So there are male trees and there are female trees. The fancy scientific name is dioecious. Now, male trees do not bear nuts. Male trees have to be dispersed through the orchard so that female trees are pollinated. And pollen is blown to female trees. Bees are not involved. You notice in my picture here, I have quite a few bees. They still tend to harvest the pollen of male pistachio trees, but they don't go to the female flowers. The female flowers have very little nectar and they're not very attractive. So they're just going to take this pollen back to the hive. Now in the San Joaquin Valley of California, we're having more low chill, or what we call warm winter years. So the trend is to plant more than one male variety. It's because in low chill years, we seem to see some offset in the synchronization between male and female flowers, male and female trees. So in Kerman orchards, just for an example, we usually use the Peters male as the standard male, but some growers are now putting the cultivar famoso in those Kerman blocks. As in low chill years, it will probably have better synchrony with Kerman in those low chill warm winter years. And I will discuss suggested pollinizers for the various cultivars in the pistachio cultivars in California presentation later this morning. Here's a typical design for spacing males amongst female trees in an orchard. A very common ratio of male to females is 1 male for every 24 females. And we generally want the female trees to be, roughly the same distance from a male. So One way to achieve this is to plant one male in every 5th tree within the row and in every 5th row. And these stars would represent males and the circles females. We have people putting them a lot further apart than this. We really don't have any data saying what is the right. In the old days, we used to have one male for every 8 females, which seems to be excessive. So somewhat depends on what kind of how many pistachio orchards you have around you, because a lot of this pollen can be blowing pretty far. How about row length? We talked about the spacing. How long should our rows be? So in general, rows longer than a 1/4 mile should have a break or access road to allow equipment to turn around if necessary. And why is this important? Because on varying years, these wagons here that collect the nuts can't hold more than a 1/4 length of a mile of road. So if you don't have a break, that poor guy driving that thing has to back up for a 1/4 of a mile, figure out some other way to turn that thing around. So again, you know, Kern County is the land of big orchards. You know, it's not an issue for a lot of people, but if we have a row longer than a 1/4 mile, we're probably going to run into some trouble. You should also have a harvest loading site somewhere adjacent to your orchard. And it should be contiguous. That means next to, you know, every 40-acre block. Now, a single loading site can service probably 160 acres because it's going to be in the middle of these orchards. And a loading site is typically about 50 feet by 500 feet in dimension. I know that seems like a lot of ground, but the loading sites can be pretty busy places during harvest. So here's some pictures of one I took. And again, these guys have a pretty nice big wide area where they can load their pistachios and put them in the trucks that are going to take them to the hauler. And they can be pretty busy too, so safety is an issue. And the more cramped it is, probably the more trouble you're going to have with possible accidents. Here's a site I took a picture of a number of years ago where things are getting pretty crowded. You got the loader here kind of crammed in with some of your replants, which can usually be hard on replants. You see there's really no room for people to get by here. This may have been enough room at one time, but probably didn't own the ground next. Somebody put a row of citrus in there. So things can change. It's best to have these things on your own ground where you have more control of them. We want to leave plenty of room around, well, any obstacle. Here I show a telephone pole, and you know, you have irrigation pumps, equipment and whatnot. And a lot of times these orchards are up against some pretty busy roads. So we want to keep our access clear and leave enough room. Generally, we want to have 35 feet between our last tree and and some obstacle. The way things keep going, probably more than that is better. Here's an example of someone having some trouble here. And these trees are still small, and this canal, like I say, isn't going anywhere. So we want to make sure we've got enough room to get that equipment around. A lot of times this is contracted harvest equipment, and they're not going to want to come back to your block if it's a real pain trying to get through it to harvest the nuts. Potential liability from pesticide drift should be considered. So we need a tree-free buffer between the orchard and neighboring schools, houses, county or state roads in a lot of instances, because you don't want your pesticide drifting onto people's cars or onto school property or whatnot. And you know, we can all claim that it's very easy to control drift and whatnot, but we have enough evidence to suggest that probably the more room you have between people's houses and roads, the better. And as I said, we want to design to minimize existing obstructions. And sometimes we can go out there and, you know, just check the property for poles. Understanding this is probably not the grower's pole right here, but and how you address this better, I don't know. But these obstructions can cause a lot of trouble with just farming in general. Another consideration is some of the plumbing in the orchard. An example of where we were shaking these trees experimentally here, and the shaker took out the air release valve for the irrigation system. This was the top of the hill. And even when they repaired it, I still think it's probably a little high. Some people are burying a lot of these orchard irrigation valves and air release valves and whatnot in these buried vaults. And that usually allows equipment to pass over them fairly easily, or at least minimizes damage. You want to watch out too, because these vaults are a great home for black widows. Let's talk about a little bit of the roads in our orchard we're designing. There's various road surfacing materials that can be used both to reduce dust and to improve wet weather access to the orchard. So there's a lot of things you want to take into consideration when we're designing our orchard. Roads, you want to take into account the native soil of the road, the current condition of the road, seasonal rainfall patterns, amounts and drainage. In Kern County, we sometimes get away with a little murder here because we don't get much rainfall. But where it does fall, it can make a fine road impassable. You want to take into account the frequencies that the road is traveled. You probably want to make our road better if it's a busy road. And then of course the cost of the materials we're going to use. And there's other issues about the ability to grade, blade, or replace or repair the road. So these are a lot of issues. I'm certainly not an expert in these matters, but I have been stuck. This is an example of the native soil used as a road surfacing material, and it's pretty much a fine silt. So you can get stuck without water. Some of the material used to control dust on farm service roads are as follows. We got, water. During harvest, water is a great thing. It really keeps the dust down. There's lignosulfate dust binders, newer recycled asphalt, heavy road oil, washed gravel, crushed rock or decomposed granite. We see a lot of decomposed granite being used in Kern County. You can use vinyl acrylic emulsions, polymers. There's organic material. Some people have even used hulls from almonds. So one place to get some pretty good information on this is the Natural Resource Conservation Service, the federal government. And it has a program to provide financial help with dust control and may help pay for some of these upgrades to the roads in the orchard. And it's not necessary to plant pistachio on a raised berm. It seems like almost every orchard I see is on a raised berm. But if you're planting on a raised berm, you should know why you're doing it. There's probably some good reasons to do it, having to do with drainage and whatnot. But again, the raised berms can be a real problem if you're cross hedging, and can even interfere with the shaking of the tree if they're exceptionally wide. Another thing to consider is you need a reservoir. And again, we're talking about needing engineering for some of these kind of things. But if you do need a reservoir, how big is it going to be? Where are you going to put it? How does the irrigation district deliver water? Sometimes if the delivery interval is so long or it comes out so slowly, you may need a reservoir. And does the district provide pressurized water on demand? In that case, you probably don't need a reservoir. If you're using a well, will you need a reservoir for pressure control or for storing water? If it's pumped at off-peak electrical rates? When you need a settling pond for silt or sand or other debris. And you can get an idea of this when they evaluate your well. There's a lot of silt that comes out of some of those wells. You gotta have some place to put it. And that'll give you a capacity for back flushing of filters and capturing, recovering drainage from the field. That's on the other side of the field. And engineering of the reservoir is an issue. I've seen some of them kind of perched on the side of high hills and whatnot. So you just don't want to take your backhoe out there and dig a reservoir. They should be engineered, especially if they contain a lot of water. And you got to realize too, at some point your reservoir could one day be labeled by a government agency as either a wildlife refuge or a toxic waste dump. So things to think about. I think our last topic is going to be options for orchard floor management. Some of the options I'm going to be talking just briefly is complete cultivation. And of course, with complete cultivation, we've got to worry about our irrigation hose, since most of the pistachios in the San Joaquin Valley are irrigated with hoses along the berms. Another option is complete vegetation cover. We have complete herbicide control. We have strip herbicide control down the tree row with cultivation of middles. We have strip herbicide control down tree row with cover crops in the middles, and we have a little bit of intercropping. So there's a lot of options. And this is probably something you should decide before you start part of the design of the orchard process. Here's strip herbicide control with cultivation. So what we do with something like this, we put pre-emergent herbicides and use our post-emergent herbicides on the berms, and we just disc the middles pretty much. And this is probably more common with younger orchards, but there's a lot of older orchards maintained this way as well. Terracing can get interesting. Remember, we can't have terraces too big. Remember, one side of the harvester comes on this side of the tree, another one on this side. So we can't have too much distance here. And again, consider those wide and high berms. Here's where we have strip herbicide control with cover crops. So in the other scenario, we were disking the middles, and this one we have a cover crop. And this can be a pretty effective means of maintaining your orchard floors, especially in Kern County. Because in Kern County by June, usually there's not much growing in the middle. So you sort of have a natural way to control vegetation there. So usually in the drier parts of the San Joaquin Valley, we probably may have to mow our cover crop maybe in the late fall or in the spring. And usually Mother Nature, by not providing much precipitation, takes care of the middle in the long hot summers. And of course, in the winter, it gets too cool for a lot of material to grow as well. I went one too many. Check one more. Just in general, talking about cover crops, we really don't know a lot about cover crops. You know, as far as insect mite control, they can be positive or negative with water relations. You know, they can help with water infiltration. But again, they use water, which is expensive, which a lot of people don't have, and you have to maintain an irrigation system that can water the middles. There's pluses and minuses with disease control, with nutrition, with erosion control, and they're definitely a home for vertebrate pests like gophers, mice, and voles. Talk a little bit about interplanting in young pistachio blocks. It's always a temptation because these trees are so small and they take so long to grow, especially since we clip off most of the growth while we're training them. So people have planted cotton in between the rows of pistachios, seen wheat between them, seen melons. And there can be financial advantage to interplanting when the pistachios are young, but make sure that you know how to grow the interplanted crop before attempting interplanting. It's a poor place to learn how to grow a crop other than your pistachios. So there's issues with weed control because you're probably using different herbicides on them. So you get phytotoxicity or drift. There's different fertilizing regimes, different irrigation regimes. You can be disking pistachio roots. There's harvest timing, shading of possibly the young trees if they get too close. And some of the crops can be a great home for meadow mice, like also called voles, insects, and mice. So there's quite a learning curve in doing this effectively. So I guess I think my time's pretty well gone, except for some few questions that are possible. So I guess plan well and good luck.
Thank you, Craig. We have a few questions in the Q&A box.
Okay.
The first question is, are there any models that have been developed to look at pollen distribution in a given orchard?
I know the answer to that is no, and those would be surprisingly difficult to do because of the way the pollen blows. So to my knowledge, there are none.
And another question is, when to use berms?
Yeah, and that gets into some issues that I'm not familiar. Generally, I think the thing that I like to use most about the berms is if we kind of have a shallow soil, if we have a real soggy, wet soil that drains poorly, I think it gets those crowns of the pistachio just out of the ground level, and it provides a little more drainage. The pistachio tree seems particularly susceptible, the crowns, to having what we call wet feet or wet conditions. So I think that would probably be my own personal decision to think about using some berms.
The next question is, if you have a lot of bees in the orchard, will that cause a decline in the amount of pollen dispersed during bloom?
If you have a lot of what? I'm sorry.
If you have a lot of bees in the orchard, will that cause a decline in the
Yeah,
amount?
we don't know that. I know that is a concern of growers because sometimes you go out there and the orchard is just alive with bees. They're all on the male trees, and you're wondering, are they harvesting a lot? Some people think it might be good that their little wing activity may be spreading the pollen. You know, again, I have to plead ignorance on that. I do not know the answer to that.
So we still have a lot of questions in the chat box. If you want to go ahead and type the answers, that would be great. We have to move to the next talk.
I understand that it's 8:30. So how do we want to handle questions? Are we going to just go back to them? I mean, can I go back to them at some point or?
Yeah, there's the Q&A box.
Oh, okay.
So you can
I'll-
just open
I'll
that
try to
and
answer
type
some of
your
those.
answers if
All
possible.
right. Thank you.
Thank you. So our second presenter is Dr. Malika Noko. She's a UC Cooperative Extension Specialist at UC Davis, and she will talk about irrigation of pistachio, system selection, maintenance, and evaluation. You can start whenever you're ready.
Okay, sounds good. Can everyone hear me all right? Thumbs up from someone, maybe?
Yeah, you're good.
Okay, great. Okay.
Before you start, we are seeing the presentation view. So if you just swap the displays, yes.
Okay. How about that?
Perfect.
All right. Well, thank you so much for having me. My name is Dr. Malika Noko, and as was mentioned, I am a irrigation extension specialist, and I actually work a lot on soil plant water relations out of UC Davis. And I am going to be talking about optimizing irrigation systems, design, operation, and maintenance today. And just a little brief overview, we're going to be talking about the principles of irrigation efficiency, how we want to optimize irrigation efficiency for pistachio, some system design options, benefits and drawbacks, a little bit about water application requirements, irrigation system evaluation, and some maintenance recommendations. And, you know, there have been several versions of kind of this talk over the years, and I noticed that some of them had many, many calculations. And I have about 30 minutes, and I don't want to bog us down with too much math. So, but the math is out there, and I do recommend, and at certain points, I'll recommend like, hey, check out this resource if you want to go out and do some of these practice calculations. So just a little bit about me and my lab, because I'm new and I haven't met many of you. So I'm calling my lab the irrigation lab, or the conservation irrigation lab. And some of the work that I do, I look at, you know, how can we optimize irrigation for co-benefits, thinking about precision management and monitoring. You know, I work with drones, and also thinking about regenerative irrigation, like how can we, you know, build healthy soils for more, you know, beneficial irrigation in the long run. And I just bring all of this up right now because this stuff is all really cool. But if we don't do a good job designing our irrigation systems and managing them and maintaining them, it doesn't matter. So really, you know, what we're going to talk about today is kind of the entry point for doing any of this fun stuff. We got to take care of our systems. We got to maintain our systems. Just because, you know, just thinking about it, like, let's say you want to get into some of this fun variable rate stuff. If your system's not going to be, you know, applying uniformly or uniform irrigation, you don't want to try to do some of this more advanced stuff. So hopefully, you know, I will help, you know, provide a foundation for designing a system that's going to get everyone to a place where you can start to think of some of these more, you know, advanced types of irrigation management. So first, let's talk a little bit about irrigation efficiency. So we define irrigation efficiency as the beneficial water use related to all of the applied water. And it's over the course of your irrigation season. So what is beneficial plant water use? Well, it's transpiration. And I think this is what should come to mind, you know, and this is what, as a soil plant water person, I think a lot about transpiration. And, you know, we try to irrigate to meet the transpiration demand of, you know, of your trees. But then additionally, you want to also think about beneficial plant water uses, you know, nutrient and amendment applications. So, you know, that fertigation, as well as pest and weed inputs, you're watering oftentimes to input all of these different things that you need to for your system. Salt leaching in areas where there's salinity concerns, frost protection, canopy cooling. Water can kind of serve as a way to really buffer your trees against frost and also against heat, which is pretty wonderful, actually, when you think of just how much water can buffer temperature. So these are all considered beneficial plant water uses. So where are the inefficiencies in the system? Like why aren't we always at 100%? There's leakage from pipes and canals and ditches. So all of, the whole supply pathway can be compromised by leaks all along the path. You can have operational losses, losses from overrunning your irrigation. Soil evaporation, percolation, runoff, wind losses, like I would consider these like water cycle losses, because, typically you're going to be really trying to focus on one part of the water cycle, which is transpiration. But, there are all of these other parts of the water cycle, and you can have losses of water to evaporation, percolation, runoff, and wind losses. And I think of these inefficiencies with the water cycle is something you can, try to manage with good scheduling as well. And I'm not going to really talk about scheduling today because I think Julia is going to be speaking a lot about scheduling and that transpiration demand component. The other types of losses or inefficiencies you can have are just pipe flushing, screen cleaning, and maintenance. This stuff is unavoidable. These are, inefficiencies that are kind of need to occur. And then chemical injection to clean pipes and hoses. So why would you want to irrigate or to increase your irrigation efficiency? Hopefully this isn't, this part's not rocket science. I'm thinking that maybe many of you have an interest in doing this just because of the cost of water, the cost of energy. You can grow more acreage with an increased water, with greater water supply or more efficient use of and control of your water supply. Disease management and plant health, we're going to get to that a little bit more with the distribution uniformity component, as well as stewardship and compliance with environmental regulations. So in terms of the cost component, if you have a more uniform application across your field, right, then you're really controlling your inputs, and you're making sure that you don't over apply or over irrigate components of your field and under irrigate others. So increasing your efficiency in that way is very important and hopefully is of interest. So I just want to kind of differentiate between some key terms because there is a lot of confusion in this area. And one is, thinking about irrigation efficiency as opposed to application efficiency. So irrigation efficiency is seasonal. We define it as the beneficial water use over the total applied water. And this is over the whole course of your irrigation season. And that's kind of the temporal component there. Application efficiency is event-based. So this is in the course of one application. How much water are you storing in the root zone with a single application versus the total amount of applied water for the single application. So sometimes, maybe you'll have a one-off and we'll have poor application efficiency for a single event, and you fix something's going on, or maybe you've scheduled, you made an error in the scheduling calculation and the application efficiency is off for, one event, but then your irrigation efficiency over the whole course of the season might be good. Or you could have the opposite case happen. You could have, a great application, but then poor irrigation efficiency over the course of the season. So definitely, think about those terms differently as you're interacting, in this area, looking at these different calculations that you can do to try to schedule your irrigation. Okay, so this is another term that, hopefully many have heard, but will become more and more familiar with, is irrigation efficiency versus distribution uniformity. So once again, I'm going to keep showing you the same equation here, but hopefully it'll be in everyone's head at the end of this. But beneficial water use, total applied water, the whole season. And distribution uniformity is just kind of a completely different concept, but it's a concept, and it's a term, and it's something you're going to want to measure, and it contributes to your irrigation efficiency. And it can be a really great contributor or detractor of your total irrigation efficiency across your whole operation. So we measure distribution uniformity for a single field. And that distribution uniformity it's the average flow of your lowest 25% of the emitters, in one grid, versus the average flow of all of the emitters. And I'm going to talk a little bit more about this, just because it is so important. And it's really, how do you ensure that you have an even application or an even application season across a given area? That's what distribution uniformity is. And in this measurement, it just kind of stems from how our systems are designed, right? Like if you design your system in a grid and you have, pressure moving water along this grid, there are opportunities for the uniformity of application to become gravely compromised. And we want to make sure that we maintain the integrity of our system and maintain the uniformity of application. And this is really an index, a way to kind of test that and have some sense of how well you're doing. Okay, so here are some pictures. And this is one of those moments where I wish that we were all in a room together, because I could ask all of you some questions and kind of do this as a little quiz. But here is an example of poor distribution uniformity and poor irrigation efficiency. In that, if you were to, take this pattern and apply it over the course of a whole season, in that, as you can see, maybe there are differences here in the pressure, there's some blockage going on or something, and you've got a lot of water being applied to this tree, and then, these trees over here are maybe not receiving as much water as they need. And, whoever is in control of the system maybe thinks a certain amount is being applied and it's not being applied. So this is what I mean when I say that the distribution uniformity, if it's poor over the course of a whole season, there's no way you can really have very poor distribution uniformity and end up being efficient. Like that math doesn't play out. But here is an example of a situation where the uniformity is great, right? We've got a uniformly distributed irrigation system, but the efficiency is poor. And the reason, and once again, if this is an event, and I recognize this is an event, but if this was a movie and we were to carry this across the whole season, this would lead to poor irrigation efficiency. And it's because every the event is going way far past the root zone here. And that's not very efficient. So the reason that this system is inefficient is because of scheduling, right? Poor scheduling in terms of thinking about how much needs to be applied in this system. And then here's our, Goldilocks scenario where we've got great distribution uniformity, perfect. I don't know if we'd ever really see this, but it's useful for this moment. And great irrigation efficiency if we were to apply this over the course of the whole season, in that, the water is being applied just to where, the root zone can extend, maybe even honestly a little past that, but, not gonna get too into this cartoon. Better than this one for sure. And also great, perfect distribution uniformity. So this is what we want to aspire to. This is the goal here. So how can we optimize irrigation efficiency in Pistachio? How can we think about and ensure this optimal irrigation efficiency? There's really three ways. One is your system design and your installation of your system. The second is how well you maintain and evaluate your system. And this is something that, you're going to have to balance the time you want to put into this with your efficiency, because there is a cost to maintenance and evaluation as well. And then the third is strategic scheduling. So that getting back to, being sure that you are scheduling and meeting the needs of your orchard, the water needs of your orchard, and keeping track of that schedule. And we're really going to focus for the rest of this talk on these two: system design and installation, and maintenance and evaluation. All right, so some system design considerations. Once again, just starting with the definition, what do we mean by micro irrigation? You hear micro irrigation quite a bit. And micro irrigation, it can be like, in terms of the actual equipment, you can have a micro irrigation strategy that's based on micro sprinklers, surface drip, subsurface drip systems, but it's really kind of this idea and the strategy where the basic design is such that you maximize the application uniformity and you maximize the control that you have over the system in terms of both the timing of water applied and also the amount of water applied. So you have several options in how you want to do this. And not every single, it's not a one size fits all scenario. There's going to be benefits and drawbacks to each one. And it's really going to depend on your system and your operation, which one works best for you, or maybe you use a combination in some cases. So you've got these micro sprinkler and fan jet combinations, drip irrigation, subsurface drip irrigation, and then the option to do single versus dual drip lines. Keep an eye on my clock. Okay. So first, let's talk about micro sprinkler and fan jet. So when you have this type of a setup, there can be a very larger wetting zone. It's maybe the largest option for that wetting zone. And they can be easy to inspect or maintain. You can have higher application rates. So these are the benefits. Some of the drawbacks are there can be increased weed growth when you're above the surface and irrigating with the sprinkler. They can be expensive. And then you can have that uncontrollable component, which is the wind and evaporative losses, depending on the time of year, the evaporative demand of the environment. You can lose water in this way by just using a sprinkler, having these droplets. That can be a potential loss. And that loss can get high, actually, especially with the wind. So it's something that's something to consider. So in a drip irrigation system, it is economical. The maintenance can be easier, and then you have limited weed growth just because the wetting zone. So this is the drawback. The wetting zone's a little bit smaller, and it can be susceptible to clogs just based on the design of the system. Subsurface drip irrigation system, there's just a lot. There's a lot of benefits, potential benefits, and a lot of potential drawbacks in that, soil evaporation can be minimized, the flexibility of irrigation timing, you have a lot of flexibility. Weed growth can be extremely limited because you're really getting right to that root zone. And then there's protection from above ground damage. But I feel like the drawbacks are pretty big here too, right? If you have a subsurface system, it can be challenging to inspect and maintain. The wetting zone is smaller. There can be this root intrusion issue, especially just thinking of perennial crops. This is a big one, right? Thinking about trees over a long period of time. There can be animal damage below ground, in vermin, damage below ground, and then it can be very expensive for herbicide protection. And I guess I would say, just to try to make this a little bit easier, in my professional opinion, based on what I've seen, like I don't know that this is a good choice for pistachio systems and for nut systems in general, just because of the perenniality of these systems. Like this seems to be much more, and I know one of the things that I'm excited about with all of you and California in general is many of you are growing pistachios, but you also might have some annual crops, and you might see that these drawbacks aren't as big of a deal if you have an annual cropping system. But if you have a perennial cropping system, once this is in, things can get kind of hairy, and I would think that some of these drawbacks really become a bigger deal when you're talking about pistachios. And we don't, and I think for that reason, we don't see a lot of subsurface drip in orchards and in nut systems. And I don't know that this is something that is going to be a good choice because of all of these drawbacks. But I did want to talk about some of the benefits as well, because I, wanted to give them a fair shake here. So dual drips versus single drips. And it's, I mean, I would summarize this with maybe double the benefits, but also double the cost of, double the energy cost, double the fixed costs, and double the maintenance. So you can have a larger wetting zone, you can increase your application rate, that's excellent, but you're going to have more to maintain. It can be challenging to inspect these systems, and then you're going to have increased costs. So this is a great example of something that I think would be more of like a consideration for your individual operation. Like, is this going to be worth it? All right, so now moving on, I want to talk a little bit about water application requirements. So how would we calculate water requirements and some example calculations. So remember, I talked about the difference between application efficiency and irrigation efficiency. So application efficiency is that one application. So here's, thinking about that single application and these three different types of systems. So drip systems, micro sprinklers, and sprinklers, they all are going to have a little bit different application efficiency fractions. And this just kind of comes into play when you're thinking about how you'd want to calculate your applied water. So when you think about applied water and that calculation, it's like you're going to factor in what the actual evapotranspiration or actual water use would be, and divide that by that application efficiency fraction. Because if you, this is at a seasonal scale, but if you were going to apply water over the whole season, you don't want to assume 100% efficiency, because then you'd end up underwatering, right? So you have a system, so we're assuming a fraction, of 0.85 or 85% efficiency. So, this drip efficiency, or in the range of this micro sprinkler, that's how you're going to want to do this calculation. And this is over the whole season. So just kind of demonstrating that, you actually need 7 more inches just to account for the application efficiency of the system. And here's a second example, just thinking about, if you were going to look at like, all right, well, what is the maximum evapotranspiration, the daily evapotranspiration over 7 days? So like, what would that look like? And how are you going to change that and apply water for 3 days? So for three days, let's just think about, okay, so we need 2.8 inches, let's just say, and divided by the application efficiency fraction of 0.85. That means you'd need to, for that particular application, apply 3.3 inches. And this is just kind of another example of how you'd maybe think about that when you want to apply for a smaller portion of time. All right, so the other thing that we need to consider are different types of soil. So there's going to be soil variability, and this comes from the magical world of soil physics, which I think is really fun, but maybe others don't. And really, it's this issue of infiltration, right? So we have different types of soil and different textures of soil, and all of those types of soil are going to have different infiltration rates. And there is some intuition here, right? In that you want to match the application rate to the infiltration in order to maximize your application efficiency, because and this goes to like how we can lose efficiency from the water budget itself. So this is the capacity of the soil. The soil can only, if you're putting water on the soil, it's like, I can only absorb so much. If you think of your soil as a sponge, and what happens to a sponge, right? If you were to hold a sponge under the sink and turn on the faucet and you turned it on too fast, that sponge isn't going to absorb the water. And we have the same thing happening here with soil. So there's this table here is based on, what is the maximum application rate for each type of, for 4 different types of soil. So, and the rates And then you have to factor in the slope, right? Because if you have a high slope, you have to slow the rate again, because that is also going to affect that infiltration. So, if slope is, but in all cases, this coarse sandy soil, you can get away with having a higher rate than if you are dealing with a clay loam or a clay. So, and also you want to think through just the system, and this is your faucet part of it. If we have the sponge on this side, the soil is the sponge, this is your faucet. How are you going to change the application rate based on the type of system that you have? And we have a calculation here as well, which is you never, just like I said, you'd want your maximum application rate to always be lower or equal, if in a perfect world, equal to that soil intake rate. As I said, I didn't want to bog us down with math, but I do think it is useful to go through some of these example calculations. And so I've got a link here if you want to check out, there's many, many more sample calculations in this particular document. All right, so system evaluation. So you're going to want to be evaluating your system and thinking about how well is it working? How well is it doing what it's supposed to do in order to keep that efficiency high? So there are a few different ways that we can do this, evaluate our irrigation system function. We come back to distribution uniformity here. And then you also want to be evaluating that application rate. And then there's going to be, a big part of evaluation is troubleshooting and figuring out, what might be going wrong. Bringing back this distribution uniformity calculation, just because now we're going to talk a little bit about it and do an example. So that average flow in the lowest 25% of your emitters over the average flow of all of the emitters. Here's an example calculation. So imagine, here's a grid here. And we have these different emitters. And so if this were all of the emitters, what are the four lowest ones? So the four lowest ones are right here. So we have 0.89 GPH, 0.70 GPH, 0.94 and 0.94. So these are the four lowest. And so what is the average flow of all of those? It's okay, well, it's going to be 0.97 GPH. Excuse me. It's of the lowest four emitters, it's going to be 0.87 GPH. And the average flow of all of the emitters, so if we just take the entire grid, that's going to be 0.97 GPH. So to get the distribution uniformity, it's 0.87 over 0.97. And that's actually not terrible. That's pretty good. Obviously 100% is the best, but truth be told, in some of the surveys that have been done, some folks are sitting around 70%. And when you think about that, that's not good. That means that many of your emitters are going to be over irrigating, and quite a few are going to be under irrigating, and you're going to see some effects, once you get to 70% or 80% distribution uniformity. So that's just kind of, thinking about like, how do I contextualize this percentage? So what contributes to distribution uniformity? Pressure differences between emitters, unequal spacing, of the emitters or of the plants, unequal drainage, or other stuff like clogging or unequal wear. And there's more distribution uniformity resources at this particular document will kind of help with that evaluation and walking through several different troubleshooting scenarios. I'm going to talk about just a little bit, but once again, when you're in that moment and you're actually troubleshooting, it's nice to have a resource. So and same here, clogging causes and prevention. When you're in that moment, you need to look at some pictures. This is another really great resource to just have, put it on your phone as a bookmark if you're trying to fix a clog or think through a clog. So just some final maintenance recommendations here. So check the pressure and flow rate of your system regularly. Flush these hoses often, clean your filters, do chemigation, fix these breaks and leaks. So that's a big one. Know your application rate, know how long it takes to run these applications, and know that distribution uniformity. and evaluate that distribution uniformity. So it's great to do a professional system evaluation every 2 to 3 years because of that, the where component of DU, that distribution uniformity is going to decrease over time. So thank you so much for listening to me. It looks like I got a little bit of time. I'd love to hear from you if you have questions or comments. And I just want to say a special thank you to Dr. Daniele Zachariah for resources and as well as some of the photos here. So thank you so much.
Thank you, Malika. We got some questions for you.
Oh boy.
And first question is, I have bicarbonate issue. Is it good to use acid in the irrigation water, or what do you recommend and when to apply?
Oh, that's a great question. And I will say that, yes, there are some specific acid formulations that can be used. And in terms of what to recommend and what to apply, I'd have to think that through a little bit more. So maybe reach out specifically. I would say, let me put can I put my email address in here? Is there a way to?
Yeah, you can drop it in the chat.
Okay, cool. Yeah, I don't want to just like prescribe. I'd like to know more. So if I send it to all panelists and attendees would be the way to do it?
Correct.
Okay. Okay. What else do we have?
And another question is, how effective is deep root irrigation for pistachios?
So I guess sorry, that's my timer. For deep root irrigation, I guess, which of the systems would that person be referring to? This is, oh, I don't see this one. I'm curious for that question, like, are you referring to like the subsurface drip or a particular strategy? Or I would like to know more about what you mean when you say deep root irrigation.
Okay, so another question is, what kind of research has been done on water use efficiency in pistachio related to plant physiology, transpiration, stomatal conductance, etc.?
Yeah, I think quite a bit of research has been done on I guess just general pistachio plant water use and water use efficiency. And I don't know, I guess I didn't want to talk too much about that because I know that Julia Marino is going to be giving a talk kind of more in that space. And I'm curious, I guess, I'm not sure when she's giving her talk. Kelly, do you happen to know so this person can tune in?
I think Julia is on the 16th of November, which is a Monday. And I think, yeah, she's giving, on that day.
Okay, great. So I would recommend tuning into Julia's talk because I definitely wanted to stick with the systems, and we kind of made this game plan that she was going to speak more to water use efficiency and the general demands of the plant and like what we know about this crop. I will say that something is very interesting about pistachio is that it is a phreatophyte. And I guess to answer the question kind of related to the deep root part, without knowing too much about what was meant by deep root irrigation, we know that the tree is a phreatophyte, and a phreatophyte means when trees have the ability to access and use groundwater. So from a physiological standpoint, we know that it's a scavenger. And it can tolerate some stress, right? Compared to an almond, for example. So actually, I think that Julia has published in that area and has done a lot of work and is going to be speaking to tolerance in terms of the salinity tolerance issue, as well as tolerance in terms of being able to scavenge and find water.
Thank you. Kelly, we have a break now. Should we continue answering questions or?
I think if it's okay with Malika, if she has the time, go ahead and proctor some questions. It is the time now for a break. So if you do need to get up and go take a break, you can. We are going to start with the next presentation at 9:15. But if you don't mind sticking around and answering some other questions, that would be great. And we can just keep going through the list until we're either done or it's 9:15.
Okay, sounds good. Yeah, I have some time. I want to know, anonymous attendee, Can you please tell us what you mean by deep root irrigation? Yeah, you don't have to answer now, but I'll just look at the next one. Okay, so the next one was thinking about the water efficiency in pistachio, so transpiration, stomatal conductance, stuff like that. Okay. And I mean, speaking to just salinity a little bit, I know that a paper recently came out, and there's a recent study that you do have to, the transpiration itself can be decreased in pistachio orchards that have been stressed by salinity. So we do know some stuff about that. But as I said, I wanted to focus more on the systems themselves.
And another question is thoughts on keep spacing emitters between trees, where emitters are spaced closer to the tree and there is a space between trees where there are no emitters.
Sorry, can I see these questions too? Where are they?
Yeah, you can, it's in the Q&A box under Zoom.
And then make sure you're on the open tab, not the answer tab.
Okay, okay. Skip
For some reason,
spacing
I cannot
emitters
copy and
between the
paste
trees,
chat.
where emitters are spaced closer to the tree and there is space between trees where there are no emitters. I mean, I think that this makes sense to me. Once again, space between the trees. I mean, I think you'd want to space your emitters closer to the tree and have a space between the tree where there are no emitters. So this makes sense to me. But once again, this is one of those things where the uniformity of the application is going to be as important or more important than like kind of these subtle changes, right? So if your uniformity is great, then you can start to make these subtle changes and expect some subtle effects. So I guess is what I would say. But it's more important to do a good job maintaining your system and maintaining the uniformity than starting to kind of make some subtle shifts here and there. All right.
So do you want me to read the next one or?
I'm looking at it, so I wanted to see. Okay, I found it. This deep root irrigation person has told me, said more. Deep root irrigation technique that is becoming available now. It is a single line drip with a soaker probed into the ground to apply water directly below the ground and avoid runoff. I don't have an expert opinion on this yet because I have not seen peer-reviewed scientific studies that have looked at this and kind of looked at it in a critical way in terms of, it sounds like a great idea, right? Like how could this go poorly? But as we've kind of learned from these systems, there's many different ways that things could go well or things could go poorly. I guess one thing that I think about right away is if you've got a soaker probed into the ground to apply water directly below ground and avoid runoff, that sounds great. But how are you going to maintain that soaker and troubleshoot that soaker? I would think that is going to add some maintenance and some extra work in terms of trying to maintain that soaker to make sure that it's working well. But I haven't seen like an evaluation study that would, do that head-to-head comparison and evaluate it over time compared to, a line drip, either a single line drip or a dual line drip just functioning regularly, and like how is that going to increase maintenance costs? Like how are we going to see that system's efficiency change, in the course of like a 5-year period or a 10-year period? That's kind of, I guess that's where I would stand on that issue in terms of, until I see those studies, I wouldn't want to say like, oh, this is the greatest or not, and until we know what these, what hidden costs there might be here. Okay. Let's see here. All right. So this is interesting. We study the yield differences I haven't seen a direct study looking at the yield between single versus drip, because I think that is an issue, or double drip, because that is an issue where you get into what did you apply? Like what does the application look like in terms of your schedule, right? We've seen studies related to the actual amount of water applied related to yield, but I haven't seen a study that would hold that constant and apply in exactly the same way and just evaluate the spatial pattern that you're going to have if you use a single versus a double drip system. But that is an interesting study. So I think that would be an interesting study to do. All right, well, it is 9:10 and I actually have to take off, but please feel free to reach out to me with additional questions. I put my email address in the box. And yeah, I appreciate your time. Thank you very much.
So we still have a few questions, and Malika is gonna address them later, and we'll be posting them in the website, correct, Kali?
That is right. I will copy these down and send them her way and see if she can get us some answers.
Yeah, and that's helpful too. And to those who kind of like had a situation, as much detail as you can provide about a situation question would be much appreciated, because then I can try to give you like the most, detailed or educational question or answer, I guess, to your particular context. Thanks.
Thank you, Malika.
Bye-bye.
So we have about 4 minutes before we get started again.
Okay, so welcome back, everyone. So for the second part of today's session, Craig Carlson will be addressing pistachio cultivars in California. Thank you, Craig. You can start when you're ready.
Thank you, Doug. Can we? Oh, can everyone see the screen?
Yes.
Yes.
Very good. Well, I'm going to get started then. Again, my name is Craig Carlson. I'm the Citrus and Pistachio Farm Advisor in Kern County. And today we're going to be talking about pistachio cultivars in California. I started working with these cultivars when I first got the job back in 1995, and the program was in progress then. So this is an extremely long-term project. I think I'll start off with a partial list of female and male cultivars that are grown in California. And as you can see from this table, that Kerman by far has the most acreage. It's been around the longest. Golden Hills is second. And then the acreage of the other one, these are just real rough estimates on my part. I don't think there's as many acres as I've been showing. When I say less than 1,000 on some of these, it's probably less than 100. So, but we also noticed that tree is dioecious. So since we have 320,000 acres of Kerman, give or take, we have Peters, which is the standard male for Kerman, on roughly 320,000 acres too. And Randy is the dominant standard pollinizer for Golden Hills and Lost Hills. So we probably have Randy on 75,000 acres in California too. I'm going to concentrate on cultivars that were released by the University of California, since I know most about those, but we have other cultivars as I showed in the previous table. So I do have some information on Red Aleppo, Sorora, Jolly, Calagucci, Aria, and Pete that were in randomized and replicated scientific trails. Calagucci is interesting, and it has a very large nut. It tastes well. I think it means ram's head in Farsi, and it's kind of got that kind of a tall look. So it's one of our more interesting varieties that's out there that's not a UC release. These are just some pictures of some of the cultivars that are not UC cultivars in general. Here's a Aria. I like Aria in some ways because it's got this beautiful sort of long almond-shaped nut, very clean white shell. Here's Calagucci again in 2007. It's a very large nut. And did some work statistically on just looking at the nuts. And Aria in 2005 and some other years tended to be the longest nut, Kerman the widest nut, and Calagucci the tallest nut. But again, we're going to deal mostly with the UC cultivars. Had one quick note, and this actually addresses partially a question I think I was asked earlier in the other presentation. We have Red Aleppo, and it's think it comes from Syria originally. It's got a very red hull. And we've got some relatives of red Aleppo too that have red Aleppo heritage. We have Ruli and we have Sorora from Australia. And whether this is the Australian Sorora or not, I'm not sure. But just as a note, it is not very precocious. That means it doesn't produce fruit very early in its life cycle. So I've got these in a relatively low chill site up in the citrus belt in Kern County. We planted it in 2010. As late as 2019, I have yet got any yield from red Aleppo, Ruli, or Sorora. Now, in this year, I did get some from red Aleppo. It has a really pretty nut, but this is something we got to take into consideration when we just choose the cultivar, is how soon are we going to get some production? And some of these varieties vary in how fast they produce nuts. Even though the nut may be beautiful when you see a mature tree, it can take a long time on some of these to produce the first nuts. So the information largely in this presentation has to do with trials conducted in Kern County and Madera County and dealing with the UC released cultivars, which again are Golden Hills, Lost Hills, and Gumdrop as the females. So it's really, we've only really been looking at 6 or 7 trials. I mean, it's only been running a long time, but it's based on limited information. So what you're seeing in this presentation is sort of my best estimate of how these things perform. Your results may vary. And the results that I'm showing are based on trials of trees of equal age growing in the same location and at the same tree spacing. So in general, younger trees tend to be ready for harvest later than mature trees. So if you've got a block there and you've got a Golden Hills in one and Kerman in another, but the Kerman are older, they may harvest about the same time when Golden Hills is younger. But when they age, you're going to find Golden Hills is going to mature earlier. And you can also get big differences across the Central Valley, you know, as much as a month very easily, whether you have trees, for example, up in the Cuyama Valley or maybe up in the Sacramento Valley versus what happens in Kern County. So the objective of this presentation is not to determine which is the best pistachio variety for California, but I want to present comparative information on the relative strengths and weaknesses of these 4 cultivars currently growing in the San Joaquin Valley. It should help you determine which, if any, of these 4 might be most suitable for your individual farming and marketing conditions. So there's no such thing as a perfect cultivar, and I'm really finding that out. So generally, there's less risk if you plant a cultivar that's been around for a long time. And you can see we've had Kerman here since the 1960s. So we know a lot about Kerman, its strengths and weaknesses. Golden Hills and Lost Hill have only got production. There's only been production information in the whole world since 2002, and it wasn't released to the industry until 2004 or 5. Gumdrop wasn't released to the industry until 2016, although we have some yield data going back to 2012. So generally, if you want to minimize risk, you go with something that's been around a long time. Let's talk about the order of the bloom. Which one blooms first? Gumdrop easily blooms first, followed by Golden Hills and Lost Hills, and Kerman blooms later in the spring. You can kind of see it here. This is these trees right here is Gumdrop. Over here we have Golden Hills with not quite the same foliage, and Kerman's in front here that's quite a bit further behind. I think it looks like it may still be in late bloom. So let's look at full bloom dates. And this again, based on our test, on average across the trials, Gumdrop has bloomed about March 28th in Kern County, Golden Hills and Lost Hills April 7th, and Kerman April 12th. So at a given location, again, for similar age trees, Gumdrop will be at full bloom about 11 days before Kerman. So it's really easy for me to determine when Kerman's going to bloom, because I just basically go out to the field, and once Gumdrop is at full bloom, I know Kerman's probably going to be about full bloom in about 11 days. I think this is an important table here. It kind of describes the synchrony between males and female trees in the San Joaquin Valley. And I kind of put this decision on which males I'm going to use back on you. It kind of depends. What do you think the future is going to bring as far as the adequacy of the winter rest period? This is really a dominant determiner of bloom synchrony. So I have described a low type of year where we really get very poor chilling or a poor winter rest period, such as happened in 2014 and 2015. I have a moderate scenario. This is kind of our normal solution. Normally we're short of chill hours in the San Joaquin Valley. And whether we're high moderate or low moderate is our usual condition. So that's a possible chill scenario. Then sometimes we get a high chill. And that's pretty rare in the San Joaquin Valley. They're predicting it's going to get rarer and rarer. So if you think you're headed for a scenario of lower chill in the future, and these blocks can last 40 years, so it can take a long time for these things. I have yet to see anybody actually remove a pistachio orchard due to old age in Kern County. So if we're believing that the world's going to get drier and sort of warmer here in Kern County, and you're going to plant gumdrop, I would use the males, the Rand and Tajon, probably 50-50. For Golden Hills and Lost Hills, Randy usually does a great job, but because we're thinking the chill's going to get less, I would include some Tajon as the early male. For Kerman, I would choose Randy as the early male and Famoso as the late male. In low chill conditions, Peters can be just terrible, and it can bloom it can be a full bloom 8-9 days after Kerman. Now for our current conditions, but we're predicting that things in the future may be low, but if you think it's going to stay the same for the next 40 years or so, gumdrop again, I would choose the Rond and Tajon. For Golden Hills and Lost Hills, Randy should be fine. For Kerman, I would choose Famoso as the early male and Peters as the standard male. You think you're going to suddenly get all kinds of chill, you're going to have very cool winters. For gumdrop, this could also be an issue for somebody that wants to plant pistachios in Texas where they get a lot of high chill. In that case, if for gumdrop, I would plant Tajon. For Golden Hills and Lost Hills, I'd plant Randy as the standard male. I include Famoso because it blooms later, and which may be necessary in a real high chill environment. For Kerman, I would choose Peters. In the old days, when we used to get a lot of chill in the valley here, people would plant Peters and they would bloom before Kerman. So we're going to plant this late male. This late male, so I think this was a question I got asked earlier. This late male is terrible under low chill conditions. It can bloom. It can take a month to bloom past its normal date, but under high chill conditions, I think it would be a good thing to include in your block. Say if I was growing these things in Texas or some parts of Arizona. So let's compare the cultivars, just give them a numbered value. So for upright scaffold and branch growth, and why is this important? Upright branch growth is a useful trait in that it reduces sagging branches in high yield year, reduces pruning requirements, and allows for closer tree spacing. The winner here is Golden Hills is the most upright grower, followed by Lost Hills. And gumdrop is interesting as it gets these really thick branches that grow straight up, and we'll talk about those a little bit later. Kerman is probably the least upright of all of these, and the one that's even least upright, even less so than Kerman, is Calaguchi. So how about a smooth graft union? Why is a smooth graft union important? That's where the scion, that's the part of the tree that produces the nuts, meets the rootstock. That's important because if we're shaking the tree and we've grafted in the wrong spot, if you try to grab that bulge that occurs, for example, with Golden Hills and PG1, you can bark the tree rather badly. And there is some thought too that an overgrowth of the scion on the rootstock may be a sign of incompatibility, which may strike at some point down the 30 or 40 years from now. So you want a real smooth graft union, Kerman's the #1 choice. Lost Hills, not much different. Golden Hills produces more of a substantial overgrowth on PG1 as the trees grow older, and gumdrop's probably the worst. It's probably the worst for overgrowing the rootstock. Forms a very squat tree, but not a very tall tree. It's sort of interesting. How about tree vigor? Why is tree vigor an issue? Usually tree vigor is associated with greater pruning and training requirements, but sometimes you can get yield sooner if you've got a vigorous tree. So Kerman is the most vigorous of these varieties shown here, followed by Lost Hills, and Golden Hills and gumdrop are less vigorous. So this kind of translates to the pruning and training requirement generally. Gumdrop and Golden Hills require less pruning, followed by Lost Hills, and Kerman probably the most. Gumdrop appears to produce very little neoform growth. So I'm not sure what that yields and what that means for bearing in the future. We haven't had these trees around a long time, but we've done very little pruning on these trees in the test trials. A uniformity of nut maturation across the tree. This is important because the more uniform the nut maturation is across the tree, the less likely you'll have to do 2 harvest shakes. If all the flowers bloom at the same time, they're a lot more liable to mature at the same time. So Golden Hills is has the most uniform maturation across the tree. The south and north side of the tree, they usually bloom and mature pretty close together. Kerman is probably second, and Gumdrop and Lost Hills often have a wider range of maturity across the tree. So this translates into how many times you have to shake the tree to get the nuts. Usually if you have to do 2 harvests, you give it a light shake first, then a heavy shake later. And Golden Hills, most of the time you can get all, unless it's a low chill year or something that messes with the nuts maturation, you can get all the nuts in 1 shake. Lost Hills, 1 to 2 depending upon the year, same true of Kerman. Gumdrop usually requires 2 shakes. So how about the order of harvest timing? Who harvests first? Gumdrop harvests first, Golden Hills second, Lost Hills sometimes with Golden Hills, sometimes with Kerman, and Kerman harvests last. And it's good to have a range. That makes the use of the harvesting equipment, hulling capacity much more efficient. So here's some of the average dates we've had over our trials. Golden Hills or Gumdrop, we've usually on average have harvested by August 20th. Golden Hills, September 1st, Lost Hills a little after September 4th, and Kerman, September 15th. And these are Kern County values. So at a given location for similar age trees, Kerman will be through with harvest about 24 days after Gumdrop. So that's a considerable period of time. And Golden Hills, Gumdrop, and Lost Hills seem to be a little more precocious. That is, they'll produce more yield, say, in year 5 compared to Kerman, but this disappears rather rapidly, and there's been no significant difference in yield among these in our test trials. We don't really know about Gumdrop. Individual nut size, Lost Hills has the biggest nut on average. Kerman, Golden Hills, and Gumdrop usually are not statistically different. In-shell split nut percentage, of course, if the shell of your pistachio splits and the kernel stays in there, you get paid for the weight of the shell. Otherwise, you don't. So in-shell split nut percentage is important. And Golden Hills, Lost Hills generally have the highest split percentage. Gumdrop varies with year. I'm not quite sure why. And Kerman usually follows. Typically, Golden Hills and Lost Hills will have a split percentage, 85% or better. Kerman is usually more around 70% or so. And they can vary a lot between fields and years. And shell hinge strength, that's how strong the nut tends to, the shells of the nuts tend to stay together through hulling. So for example, if you run your nuts through the huller, some of them will fall apart. This is the tendency for them to fall apart. And Lost Hills has a tendency for the nuts to fall apart more so than the other cultivars. And it's usually not terrible. In our trials, it's average about 3% lost shells and kernels. And usually you lose the kernels. You don't get paid for any kernels either because they get all chewed up. Kerman Hill and Golden Hills has been less than 0.5%. So these have a tougher shell, less likely to fall apart. But personally, if I've got some to eat, I prefer Lost Hills because they're much easier to open. The ones that make it through the hull are okay. Who's got the cleanest or the whitest shell exterior? You don't get paid for this really, but it is bad if you do get dark stain. You get those aren't sold. You don't get paid for the weight of the shell if you've got dark stain. So I think Kerman has the whitest shell of these. And there just seems to be more staining with Gumdrop and Lost Hills. Golden Hills is very close to Kerman. How about blank nuts? These are harvested blank nuts. When we do our trials, we don't clean all the blank nuts off the tree. We just measure the ones that did fall into our harvest shaker. In general, Golden Hills and Lost Hills have had the less blanks, Kerman the most. Of course, you don't get paid for a blank nut. Seedless citrus are, you get a real premium for those, but seedless pistachios, it's the opposite. The degree of alternate bearing at 12th leaf. In our trials, Lost Hills has had considerably less alternate bearing than these other cultivars. Gumdrop is severe alternate bearing. Some years we don't get anything one year, the next year it's all there. So it's I think that's not a good thing for the industry. Lost Hills, and when I'm talking to some people that have Lost Hills commercially now for some years, they seem to be seeing the same trend toward less alternate bearing. A serious disease of pistachio is Botryophyria panicle and shoot blight. And it's not so bad in Kern County because it's more moisture related, but this can be a real issue further north. And Dr. Michelides, you'll be hearing him later in the course, I believe. He's done some research on this. And Golden Hills, I think it appears to be a little more susceptible. I don't see these differences in Kern County, however, because we just don't see much Botryophyria anywhere. This could be a real issue at points north, though, like for instance at the Hema Valley, for example, where they may get 30, 35 inches of rainfall a year, precipitation. This could be a real issue. And Golden Hills and Lost Hills and Gumdrop were born and bred in Kern County, so we really don't know what they'll do at points north where it's wetter. Alternaria late blight, another fairly serious disease of pistachio. This I do have some firsthand experience with in trials, especially some in the one in Madera County and in some wetter spots in Kern County where we don't get good air circulation, and Golden Hills is more susceptible to alternaria late blight than is Kerman Gumdrop. Well, I'm not sure about Gumdrop, but Lost Hills. There are places in Kern County where I really recommend people spray Golden Hills, whereas I have less of a tendency to suggest people do that with these other varieties. So we all have an issue of the ability of the trees to exclude salts. And you think that'd be more of a rootstock effect, but we see it very obviously in Golden Hills. It tends to absorb more boron into the leaf than does Kerman or Lost Hills. Gumdrop we don't have any data for. So this is showing some leaves fairly early in the season. I think this is July or whatnot. And this is an area with low boron in the water and low boron in the soil, although there's a lot of unavailable boron in the soil that I think is leached out with acid fertilizers and whatnot. But where you have a lot of boron in the water or a lot of salts in general, I would not plant Golden Hills. Low chill symptoms on the tree. So what are low chill symptoms on the trees? People ask me, well, which is the most chilling sensitive or insensitive? Which is the most variety that's most tolerant of low chill? And I really can't answer that question. We do have a trial in the Coachella Valley where there's very low chill. You might be able to help answer that question at some point, but if I rate them based on what I see in the field as low chill symptoms, although I don't know how this relates to yield, for example, in the alternate bearing pattern. But low chill symptoms include something like delayed bloom or extended bloom, especially between the north and south sides of the tree. Flagging of shoots. This is where we get some leaves at the very end of a long shoot, but nothing in between those shoots that are lower down. And we get early nutlet drop or nut blanking, poor yield. So in general, kind of ignoring the poor yield thing, which we haven't investigated, Gumdrop shows the fewest low chill symptoms. And this kind of correlates with data from other fruit trees where the trees that bloom the soonest tend to have less of a chill requirement. But how this relates to yield, no data. Kerman is probably I see more in my test plots, I see more low chill symptoms on Kerman than I do these other two. But this is an area that needs a lot more investigation. And just covering this first section of my talk, we recently wrote an article for California Ag. Here's the citation or the link, and it gives more detailed comparisons, more numbers for the comparison between Kerman and the UC varieties, if you're interested in learning more on that. I want to talk a little bit about Gumdrop. That's our latest release, and right now there's probably less than 30 acres in all of California. And it's sort of unique, and the way it grows is unique. It's got these very thick branches that head up, and then once it gets to be a certain size, we just don't get much new growth or neoform growth. It just get a small amount of growth with fruit buds again. So there's a lot we don't understand about Gumdrop. So I'm not recommending growers with little experience growing pistachios or for growers with small acreages to plant gumdrop. Right now it's ready for commercial harvest before the commercial nut processing plants are ready to open or accept nuts. So if you're a small grower, you may not have any place to take your nuts. So I'm suggesting that if people want to plant gumdrop, it should be planted by grower operations having access to a plant that is capable of processing the nuts when they're ready for harvest. So you got to have the ability to open your plant. Air temperatures can be hot when gumdrop is ready for harvest, and the nuts do not hold well on the tree. So you want to get them off there and get them to the plant and get them processed. Gumdrop is showing more growth variability on UCB1 seedling rootstock than it has, for example, on platinum in a block we planted in 2014. Gumdrop will perform best on well-drained soils where water ponding does not occur. It seems to have more trouble with molds. So in the San Joaquin Valley, a timely double shake harvest is suggested for gumdrop. Depending on the season and location, the first harvest will occur in early August with the second shake a week or 10 days later. Also, at the processing plant, gumdrop has a lower net dry load weight percentage than other cultivars. And what that means is that a smaller percentage of the harvested material transported from the orchard to the processing plant is payable, or more, I guess, trash, if you will. Golden Hills really generally beats all the other cultivars in that most of what you haul to the processing plant is payable. You're paid for that weight. Later in the season, some to many nuts produce a drop of gum on the hull. That's why we called it gumdrop. So gumdrop harvest is stickier than a Kerman harvest. Gumdrop is very precocious, so it'll produce a lot of yield early. But it's an extreme alternate bear when it starts getting older. So you might get 5,000 pounds one year and nothing the next year. I mean nothing. The nuts look similar to Kerman and Golden Hills. They all look like pistachios. So personally, say, why would you plant gumdrop? Well, I see the best fit for gumdrop as a cultivar planted by large, well-capitalized companies that can harvest the gumdrop trees quickly, efficiently transport the nuts to a processor that they have control over so they can open when it needs to be opened. And that's probably be the first week of August in the southern San Joaquin Valley, a lot of years. So what's the advantage? The advantage of having something that you harvest earlier is that the peak industry-wide harvest demand for harvesting, transporting, and plant processing would be reduced compared to what would have occurred had they planted cultivars that are ready for harvest in the existing harvest window. So that would be the advantage. And it can be a big advantage. If you don't have to increase your processing capacity, you don't have to buy more harvesters, you don't have to have more peak numbers of laborers. We can spread them over a bigger time period. That is a big advantage to the industry. Let's talk about the Golden Hills cultivar. The reason I'm focusing on this one is it's gained the most acceptance by growers recently. There are probably about 85,000 acres of Golden Hills and Lost Hills in the ground in California and Arizona right now. So, and most of that acreage is still non-bearing or just coming into bearing, because about 55,000 acres were planted from 2009 through 2015. And most of the acreage going in now is Golden Hills. And obviously, as we're planting these things in wider areas across the valley and in locations where we didn't have test trials, we're learning a lot about Golden Hills. And this is really the way we evaluate a cultivar. And again, this is why I mentioned that the longer the history we have with a cultivar, the more we know its strengths and weaknesses. And there's no such thing as a perfect cultivar. Golden Hills has proven more difficult to bud than Kerman. The reason is not clear, but I think it has to do with the bud sticks. They taper radically along their length. So bud maturity is often quite variable along the bud stick, with the older buds being too large and the smaller buds too green or immature. So my suggestion is to have a nursery licensed to distribute UC Budwood and is familiar with budding Golden Hills to do the budding for you. And we're getting people that are more and more experienced and more successful grafting Golden Hills. I think I touched on this earlier. The growth habit of the canopy of Golden Hills compared to Kerman is less vigorous and more upright. So for spacing, again, we probably have to have our standard 19 to 20 feet between the rows. We've got deep, well-drained loams and clays. We can probably put them 17 to 18 feet apart. Even on these, some people are putting them 16 feet together. And again, we talked about that in designing the orchard. That's probably going to be more work later. And you can put them a lot closer on less productive soils. But again, as I mentioned earlier in this talk, if there really a lot of sodium and chloride and boron is excessive, I think I'd choose something other than Golden Hills to plant. And we also have to realize that since Golden Hills flowers early, and this would obviously be true of gumdrop as well and Lost Hills, I like to sort of at the latest, I'd like them to be tipped. That is, these long branches, tip them before you get to mid-February. If you can get it by the end of January, so much the better. The trouble is that when you have a long branch and it starts warming up, those apical, those last buds will start producing an auxin, which tells the buds below not to push. And we want to cut off that bud before it gets to that stage. Otherwise, that bud's going to tell all the buds down below not to push. So that's what's happened here. So these trees were pruned obviously before we had leaves. They came in a little late. They cut the top off, but it had already produced auxin that told these buds not to push. So we get this rather strange look. This look also happens when we have low chill years. When we talk about the flagging branches, I don't know what's happening there, but generally if we had plenty of chill and you see this, it probably means you tip those branches too late. And everything in Golden Hills happens as much as 2 weeks earlier than what happens in Kerman. So some training pruning suggestions. We like to prune Golden Hills hard during training. That's when in the non-bearing years to encourage more branching and greater outward spread of branches since it wants to grow upright. But once it starts coming into bearing, we want to reduce pruning compared to Kerman because those branches tend to remain more upright and there's a lot of yield inside the tree toward the end of those branches. Again, we don't seem to get as much new growth with Golden Hills as we do with something like Kerman. So the training there's another issue with training, and this is particularly bad in years with low chill when even the vegetative buds don't really get the word that winter's over and they can push. So generally we get poor bud push below the training cut. And if things are really bad, you may end up with only one bud pushing, which means you've basically done nothing by trying to cut the limb so you get additional branches. So if you don't see the bud, don't cut here. If you cut here with Kerman, a lot of times you don't even see the bud, you're going to get a branch to push here, but not with Golden Hills. So we want to see some big buds where we make our cut. So here I would attempt to cut here, not here, because I don't think it's going to do anything for it. So in general, when we're doing even our winter pruning or our initial mid-season prunings that we do early in the life of the pistachio tree, which I think Bob Beatty is going to tell us more about a little later, we want to make sure we see a bud before we make our training or pruning cut. This is something that just showed up this year, I guess a little bit last year. It looks like big bug damage is worse in Golden Hills. And the reason is it appears that when Kerman gets stung by a big bug, like a stink bug or a leaf-footed bug, it'll drop the nut. It realizes the nut is no good. But it looks like Kerman like Golden Hills hangs onto those nuts. And the bad thing is, we call this epicarp lesion. The bad thing is this can end up in the final product. It's difficult for the processing plants to sort this data out, these kind of nuts out. So I guess my advice is that if you've got a Golden Hills block, we need to put some special efforts into finding those big bug populations and controlling them. This just shows some pictures I've taken. Typically in a lot of orchards, we see this kind of thing, and that usually means that we've got some big bugs in action, in July and August and whatnot. And we don't see as much of this with Golden Hills. If you go through a Golden Hills block, you don't see a lot of black stuff on the nuts, but that could be a bad thing because in Kerman or something, that means it's going to drop some of these nuts. We don't have to worry about it. We lose the yield, but we don't have to worry about it ending up in the final product. So we need to be out there looking for these guys. And here's some nymphs. They're not that easy to see. So need a sharp eye. And once you start seeing the nymphs or even the big, you got to start thinking about maybe we need to spray things out here and get rid of these guys. Another thing we've noticed about Golden Hills, it has more of a tendency to split. I think it is because it is more of a gracile tree, I guess, or you don't get the thickening of the branches like we do in some of the other varieties. And so if you start seeing stuff like, or even well before this, we call this a tree, as you say, it's smiling, but it's really not a happy smile. So before this happens, we want to put a threaded rod through here, a fairly thick diameter rod that's got washers on both ends and nuts. We're going to just kind of screw this thing together, I guess. You can see an example here. And one of the problems is the way we prune trees here. We encourage all of this stress of the tree to meet right here at the crotch, and that's just asking for a problem. So if you only got 2 branches, there's a good chance these things are going to start smiling, as it were. But it can happen with 3 or 4 branches. So again, especially when they're younger, when they're just coming into bearing, we want to make some trips through the orchard and bolt these things together. This usually works fairly effectively. But that's why I am excited about the single leader training, where we train the tree so we don't have all this stress at one point on the tree. And I'm working with some growers too, along with, of course, not leading any of this. Bruce Lappinen is, and others have been working with this, but I've still been watching it closely, and I think it may be worth pursuing. So how about pre-harvest dry down? I've heard almond growers use the term dry down to refer to the process of drying out the orchard, particularly the orchard floor prior to harvest, which is important for almonds because they don't shake them onto tarps like we do or onto catching frames. So they need to have a dry orchard floor. But unless you have the soggiest, highest saturation percentage soils in the San Joaquin Valley, you want well split nuts. The term dry down should be deleted from the vocabulary of pistachio growers, particularly growers of Golden Hills. It's hot when Golden Hills is ready for harvest. The trees will be transpiring at very high rates. For many blocks, if you can't get in and harvest the nuts within a few days of setting the water off, you should find out why you can't. If the orchard is too wet to get equipment in, fix the leaks in the irrigation system, correct the irrigation distribution inefficiencies, adjust your irrigation scheduling, do what you need to do. If the harvesters do not show up when they're supposed to, have a serious talk with your harvest contractor. There's no reason to have a bone dry root zone prior to or immediately after harvest. And part of this is not the harvest contractor's fault because there is we have so much acreage ready at one time that even the slightest delay can really mess up the harvest schedule. So you could end up having those harvesters come in a week or 2 weeks early fairly easily. Other thing we found out is the leaf canopy of Golden Hills appears to be more sensitive to scorch and subsequent defoliation as harvest approaches than Kerman. So this is scorch. And we've seen it's more prevalent in male trees, but it's more prevalent in Golden Hills than in Kerman, for example. So we want to ensure that adequate irrigation exists throughout the season, but especially during the last 3 to 4 weeks before harvest, which is important for nut split too. We want to minimize irrigation interruptions for crop pesticide spraying. This is the biggest thing I noticed, where again, the sprayers don't show up when they're supposed to, and the grove dries out excessively. And again, that has to do with how well your irrigation system is maintained and soil type, stuff like that. And I'm also suggesting that we avoid late season chemical sprays if possible. Obviously, we got to control our navel orange worm, but we have some people that probably spray excessively. And pistachio does a great job of absorbing nutrients through the soil. If you do need to put on some sprays later in the season, I would avoid using chemical adjuvants or spreaders that are known to have a higher risk of phytotoxicity, and use lower rates if possible. I want to talk about harvesting Golden Hills. Golden Hills nuts don't have to tatter. You shouldn't use tatter as one of the guidelines for when you should harvest. These nuts, you can see the hull is intact. It's not tattered, it's not split, but those shells underneath in this particular case are split. So basically with Golden Hills, once a majority of the hulls slip, harvest can begin. The greenish tight hulls are most likely blank, so it doesn't matter, no use waiting for those. Most of the nuts will be split and ready for harvest, even if the hulls remain intact. And the nice thing about intact hulls, there's some evidence that reduces navel orange worm infestation. So in this picture here, these nuts are ready for harvest. Now the hull may feel somewhat firm on some of them, but generally I would err on harvesting a little early, because if the hull are usually that hull will come right off. I need to talk a little bit about the double shake. This has to do with the fact that Golden Hills nuts mature fairly evenly and quickly across the tree. So I define a double shake as when an orchard is harvested twice and roughly equal weights of nuts are harvested within each of the two shakes. A double shake is composed of a light initial bump shake in which the clusters are not removed, and a hard shake roughly 10 days or so later, which some of the clusters will come off, obviously. So if more than 90% of the total nut load is removed during the first shake, I would call the following shake more of a sanitation shake. I just want to get it clear what the difference between a double shake and a single shake and maybe a sanitation shake. And we don't want to do our sanitation shake too hard for Golden Hills. We don't want to split the crotch. So again, the relatively short bloom period for Golden Hills translates to a more even nut maturity across the tree than say is true of Kerman or Lost Hills. So what I'm trying to say is for Golden Hills, a double shake is often unnecessary. When the hulls of the most advanced nuts begin to slip and are ready for harvest, waiting an additional 8 or 10 days will usually allow you to get 95% or more of the nuts in a single shake. Don't rush to harvest. Trouble is, if like we do in Kerman, if we shake when 50% of the nuts are ready, the nut maturity is so even across the tree that you probably have to come back in a few days to get the rest without having those other nuts lose quality by staying too long on the tree. So again, by waiting until 95% or more of the nuts are ready, you'll get the majority of your crop off well before the first shake of Kerman and suffer a little loss in terms of nut quality that will occur in the second shake of Golden Hills is delayed, which often happens. I mean, there's no way you can shake and usually come back within another week or something to get the rest. I mean, it's hot when Golden Hills is ready for harvest and they're not going to store well on the tree. So, and how do we tell if we've shaken too early or too late? There's usually high levels of adhering hull and dark stain at harvest. This is data you get back when you take your nuts to the processing plants. And assuming they process them in a timely manner, you've got a lot of adhering hull and dark stain. It means you probably harvested too late. If only the percentage of adhering hull is high and stain percentage is low, suggests that your harvest may have been a little early. The yield and nut quality data for Golden Hills in our studies were obtained in small trials within larger blocks of Kerman, because that was the only place we could put them if we had cooperating growers. So Golden Hills, after harvest, were irrigated based on the full irrigation requirements for Kerman, which had not yet been harvested. They were trying to get high split, so they received a generous post-harvest irrigation. So, and what I'm suggesting is that you probably do the same thing if the leaves are green. With the leaves are green, remember the canopy, they're still photosynthesizing, they're still storing carbohydrate, which will get used for nut production next year or perhaps the year after. But it will translate into nuts, and then that's probably money that ended up in your pocket. So if possible, we want to maximize photosynthesis going into the fall. We don't want to overwater, but if green leaves are present, I would continue irrigation and avoid the dreaded dry down. The UC cultivar Lost Hills, this is just a note, is becoming increasingly popular with some California growers, maybe because of some of the problems we're seeing with Golden Hills, I don't know, but we released that for a reason. We think it's a fine cultivar as well. And just as a final, I think our Office of Technology Transfer wants me to say this: it is not difficult or expensive to become a licensed producer of UC budwood. We have nursery, butter, and private grower licenses that are available from the University of California, so people can produce these cultivars. And if you want to find out about the licensing requirement or using these, please contact Denise Mead at UC Davis, and there's the contact information. With that, I think I'm through with the presentation. Guess we have a little time for questions.
Thank you, Craig. You got over 20 questions.
Well, we're not going to have time for all those, I don't think.
Yes. So we're going to try to answer at least 2 or 3 of them.
And I'll get back to the other ones like I did in the previous talk, just in the question and answer box.
Okay, perfect. Thank you. And the first question is, in a low chill year, is Famoso earlier or later than Peters?
Famoso is earlier than Peters. And of course, the big question is, how does it match with Kerman? And in a low chill year, Famoso is going to do a much better job of matching with Kerman.
And regarding Kermans, what is the recommended plant spacing?
Well, that kind of depends on some of the things I said. You know, it depends on how good your soil is, your water quality and whatnot. I would never plant them wider than 20 by 20. That's 20 feet between rows and 20 feet between trees. I think there's some very good orchards out there with, you know, with tolerable salts, tolerable water and whatnot that are planted at 19 feet between trees, or 19 feet between rows and 17 feet between trees. I think I'd be, because of the size of the equipment, I might go 20 feet between rows and 17 feet between trees. I think that's a good spacing for Kerman under most of our conditions.
So have you noticed low yield in Kerman young trees, 6 to 12 years old, and compared to other cultivars?
Yeah, and you got to realize too that, you know, yields in younger trees are, it really depends on the chilling conditions we had and whatnot. They tend to want to be vegetative. So if we get low chill years, they tend to be more vegetative and yields suffer. So and depends how good a grower one is, and you know how well he selected our site where we have our orchard. So that's a tough question to answer. In general, I think my time's up, but in general, I don't see a lot of difference in yield. Maybe the first couple years I see some advantage to the UCB or the UC release cultivars, but in general, yields have been not that statistically different. Some blocks have been different than others, but in general, I am having trouble separating the yields statistically.
Okay, thank you, Craig. We have to move to our next talk. And then if
Thank you very much, Doug.
Thank you. Our next presenter is Elizabeth Fitchner. She's a UC Cooperative Extension Advisor for Tulare County. Unfortunately, due to scheduling conflicts, she wasn't able to join us in person, but she was kind enough to send us a pre-recorded presentation on pistachio rootstocks that will be playing right now. And please type your questions into the Q&A box in your Zoom control panel, and Elizabeth will answer them later on, and the answers will be posted in the website.
Hi, my name is Elizabeth Fitchner, and I am a farm advisor with UC Cooperative Extension in Tulare County. My talk today will be about pistachio rootstock. First, we'll start from the very beginning, and that would be, what is a rootstock? Well, a rootstock is the trunk or the roots into which the scion material is inserted. The juncture of the rootstock and the scion is what is known as the graft union. The T-bud is the most common method used to bud the pistachio scion onto the rootstock. That term T-bud is generated by the T shape of the cut here, and the shield is cut from the bud stick and inserted into a T-cut on the rootstock. Trees that are planted in spring for pistachio tend to be budded in August. At first you might think, why use a rootstock at all? Well, there are several reasons that a grower will benefit from the use of a rootstock. One might be the enhanced freeze tolerance of a rootstock. There might be disease or pest tolerance. A rootstock might be adapted for soil and water quality of a given area, and there might be horticultural properties of value to a rootstock. In the early part of the pistachio industry in California, rootstocks were really what ended up saving the industry at the early point in time. This was a paper written by Joe Moranto, a farm advisor located in Kern County. In the early part of the industry, 1969 to 1975, there were about 14,000 acres of pistachio that were planted in Kern County. This acreage was planted on Pistacia atlantica and Pistacia terebinthus rootstock. And all of a sudden, there was no planting at all between 1975 and 1980. And the reason for that is the emergence of a disease called verticillium wilt. And verticillium wilt was wreaking havoc with the plantings on Pistachio atlantica and Pistachio terebinthus rootstock. What happened is with the emergence of Pistachio integrarima, a seedling rootstock, a new hope and momentum was given to the industry, and that's because this P. integrarima rootstock was resistant to verticillium wilt. And in fact, the word integrarima in Latin means incorruptible, sound, unimpaired, or having great vitality and force. When you think about it, the early pistachio industry had been planted on ground that was formerly cotton ground, and the soils were infested with verticillium microsclerotia. And so we needed a different rootstock that was resistant to that pathogen in order to save the industry and allow it to expand to what it is today. This photo shows the symptoms of verticillium wilt. What you can see is that the pathogen, which is a fungus, will grow from the roots up the tree, and it might even only cause symptoms on part of the canopy, like half the canopy, because the fungus literally just colonizes up the vasculature of the tree and causes wilt symptoms. This is a tree, a photo that I took here in Tulare County within the past couple of years, and here's a situation where the scion of the tree collapsed, but the rootstock is healthy. And yet you have a dead tree, or really a commercially non-viable tree. And in this situation, the rootstock was actually resistant to the pathogen, which was Phytophthora, but the scion, Pistachio vera, is susceptible to the pathogen. So in this situation, the problem was actually not created by the rootstock. The rootstock was doing its job, but the pathogen was introduced by water hitting the trunk above the graft union. So here's a close-up picture of that scenario, where you have the scion of Pistachio vera, where you have bleeding on the trunk, and you get an aerial canker that was caused by the Phytophthora pathogen that was just introduced on the irrigation water. Basically, those micro sprinklers were spreading the water too far, and they were hitting the trunk of the trees. Pistachio rootstocks are generally planted in advance of budding. So here's an example of a crew going through a pistachio orchard, and these trees are still in the rootstock phase, and they've not been budded yet. This is a bit different to one of our historical nut crops in Tulare County, the walnuts. Walnuts are typically budded in the nursery and sold as budded trees. In the pistachio nursery trade, you can also buy budded trees. However, they're a little bit less common. When you look at a pistachio field or a pistachio orchard, you're not really looking at a single genotype. I like to make it simple and say that you're looking at two different genotypes. It's almost like two different plants, the rootstock on the bottom and the scion on the top. In effect, you're kind of looking at three different plants because you have the rootstock on the bottom, and then you have the scion of the female on the top, and every fifth row, every fifth tree is that male plant. So it's actually three different genotypes within the orchard. Here's a list of the commercial rootstocks that have been used in California from the 1970s to the present. In the early part of the industry, as I mentioned before, we used Pistachio terebinthus and Pistachio atlantica, but they lost favor due to their susceptibility to verticillium. Pistachio integrarima saved the day because it was verticillium resistant. The problem is it's a bit more frost sensitive, and it didn't allow acreage expansion into the cooler areas. We now have these interspecies hybrids that are utilized in the nursery trade today. One is UCB1 and the other is platinum. UCB1 and platinum, you'll notice, have the same parentage. The difference is actually quite subtle. It's which parent is the female versus which is the male. We call them the reciprocal cross. If you look at this within a seedling population, there's variability in the seeds that are produced from these crosses. With the platinum, This verticillium resistant selection from this population was chosen, and it has been put into clonal reproduction. So UCB1 is verticillium resistant and frost tolerant, and it has some salinity tolerance. So UCB1 is an interspecies cross. It can be purchased as a clone or as a seedling. Platinum is also an interspecies cross, and it can only be purchased as a clone. PG1 is a single parent, that is the Integrarima seedling, and it is purchased only as a seedling. These are the rootstocks that are currently utilized by the California industry. Now, why do you not use platinum as a seedling? It's because the seedling population is variable, and it's variable enough that verticillium resistance is not stable within that seedling population. So it's propagated as a clone. Pistachio rootstocks may be propagated both sexually, and that is by seedlings, or asexually as clones. The seedling rootstock population is generated from seed, and clones are generally referred to propagation in micropropagation in tissue culture, like this photograph here on the right. To generate UCB1 seedling rootstock, you cross a Pistachia atlantica female plant with a Pistachia integrarima male. The seeds are then produced on the female tree, and when those seeds are harvested and planted out, we end up with a UCB1 population. These are all UCB1 seedlings, but my icons demonstrate that there is slight variability between individual seedlings. Seedling production for pistachio rootstock is a little bit more complex than just harvesting a bunch of nuts and growing them out in a nursery. It requires a level of precision. Pistachio species are dioecious. That term means two houses. And that means that there's a female house or female tree and a male house, male tree. And the trees are wind pollinated. So it's very important that the crosses are controlled. To achieve this, pollen is collected at anthesis. It is stored in a freezer. So to produce the UCB1 seed, you would collect the pollen from Integrarima and store it. Then you apply the pollen to Atlantica female tree at bloom several weeks later. In the photo, you can see the pollen coming off the male flowers when a branch is shaken. The female trees or the female flowers have to be protected so that only the pollen that you want is actually coming in contact with the female flowers. So these trees are actually built inside structures so that you can put up tarping and prevent pollen from coming in. Here's an example of a Pistachia atlanta Kearney Ag Center mother tree. And it would be under an area that can be tarped during anthesis. And this is an example on the right of the UCB1 seed that is then harvested for the nursery tree. These seeds are then germinated. They're grown up as little seedlings, and they can be reared in wholesale nurseries in pots or container culture. In this photograph, you can see the seedling or small tree population that resulted from UCB1 seed. And the first thing that you'll notice is the heterogeneity. You have individuals that are clearly taller than others. So you don't have a uniform stand even at the rootstock level. So when you think about it, these same trees, when they're placed in a field or an orchard situation, there will be variability in the orchard. So that might be compounded by variability in the soils throughout an orchard, microclimates, etc. So this basically is yet another contribution to a lack of uniformity in the field. Choice rootstocks from seedling populations may be selected for asexual or cloning propagation. Selections may be made for vigor, disease resistance, compatibility with scions, and tolerance to soil and water conditions. If a selection is made of an outstanding genotype from a seedling population, it can then be placed into tissue culture that allows for a rapid multiplication of plants. This is generally done with axillary bud proliferation. So these clonal plants are derived from micropropagation. Micropropagation is the practice of rapidly multiplying stock plant material to produce a large number of progeny plants using plant tissue culture. Within the pistachio system, we tend to use proliferation of axillary buds. That's propagating off of already formed or preformed meristematic tissue. This is different than the use of adventitious systems where there's a higher mutation rate. So that's one reason why the axillary bud technique is beneficial. In general, these micropropagation labs can achieve approximately 5 times proliferation per month. More is possible, but the more you do, the more of a risk there is of an epigenetic variation. So what is an axillary bud? An axillary bud, I've circled them in the photo. These are located at nodes. So those buds are excised and put into sterile tissue culture. This is called micropropagation. So where do these clonal lines come from? Well, they all start with a seedling population. So here's an example of how you can end up with multiple clonal lines of UCB1. We start with the UCB1 seedling population, and I use icons to sort of suggest that there's some different genotypes and slight phenotypic variation among seedlings. Now, let's assume nursery or lab A sees this one genotype or selection and they think, gosh, this is really splendid. I'm going to propagate this UCB1 and I'm going to call it my splendid UCB1 clone. Okay? And so there's one clonal line of UCB1. Then you have another lab over here, lab B, that really likes this one, and they think it's the magnificent clone. And they micropropagate it. They select it and they micropropagate it. It's still UCB1, but it's just a slightly different line. And you can end up with multiple versions of UCB1 being micropropagated. So the take-home message here is that there may be variability between clonal lines of UCB1, but there should be uniformity within clonal lines of UCB1. For example, within this one clonal line of UCB1, the magnificent line, they should be uniform. Or is this the splendid one and this is the magnificent one? Okay, so you should have uniformity within clonal lines, but variability between clonal lines. And this is very, very frustrating because not all industries have the same terminology. Why are all of these clonal lines still called UCB1? Well, because they're all still the same UCB1 cross. They're from that same seedling population. However, when you look at walnuts, Paradox walnut rootstock is an interspecies cross between Northern California black and English walnut. When you end up with these paradox seedlings and you select ones that you think are superior and you make them into clones, we actually give them different names. We have VX211, that's from the Walnut Improvement Program, or Vlach, which was a selection from private industry. So it's actually much easier to differentiate between clonal lines within the walnut system than it is within the pistachio system. So I'm hoping that that makes it clear, because I know that it can be very confusing, particularly when growers are growing multiple crops. A series of rootstock trials were conducted in California between 1989 and 2002. at different places within the state. These different trials looked at verticillium tolerance, yield, cold tolerance, salinity tolerance, etc. These rootstock trials allowed us to gain valuable information during anomalies within the weather systems. For example, in December of 1990, there were 11 nights that were extremely cold, between 4 and 12 degrees Fahrenheit. So researchers that conducted these studies were able to look at how these rootstocks performed under these cold conditions. For example, the Atlantica seedlings had no mortality, suggesting that the Atlantica component of the UCB1 parentage was probably what offered some of that cold tolerance to those UCB1 seedlings. Also, the UCB1 seedlings had no mortality, and the PG2 seedlings had very low mortality. It's important to mention that these PG2 seedlings are the reciprocal cross of UCB1, and one of those seedlings was what gave rise to platinum. So it's not really fair to compare them directly to platinum, but it was like a progenitor to the platinum clone that is available in the nursery trade today. So cold tolerance was associated with Atlantica parentage in the UCB1 and platinum rootstocks. At the West Side Field Station, a new trial was planted in 2019 by May Cullenber and Bruce Lampinen. In this trial, they have UCB1 and platinum rootstocks, and they're looking at the influence of the last irrigation date on cold tolerance of these young trees. Basically, it's to answer that question of when should we cut the water off. These rootstock trials also allowed researchers to evaluate how these rootstocks performed under increasingly saline conditions. In these studies, trunk diameter was measured on Kerman pistachio as the scion as a function of increasing salinity. And what the researchers found is with increasing salinity, the UCB1 rootstock was able to maintain a higher trunk diameter than either Atlantica or P. integrima. And remember, P. integrima was that seedling that really saved the pistachio industry from verticillium, but under saline conditions, UCB1 does perform better. At the end of the day, the most important concept from a grower might be what's the cumulative marketable yield from these trees. So one of these rootstock plots allowed us to look at the yield from female trees that survived through 2002 in a trial that was in a verticillium infested soil in the San Joaquin Valley. So evaluating trees that were of excellent vigor or good vigor, if we look at the yield, those UCB1 seedlings and PG2, the reciprocal cross, were high yielders. P. atlantica, which of course, it offers the frost tolerance, but also the susceptibility to verticillium, was also statistically similar. Similarly, we have high production. These were not statistically different, all of them. So at the end of the day, that UCB1 seedling is a very good producer, maintains high yield. The platinum, the reciprocal cross, is verticillium resistant and is also a strong productive selection. Atlantica, our historic rootstock, it's susceptible to verticillium, but it was a good rootstock and it's what conferred the frost tolerance. And Pistachio integrima, that's where you get the PG1. It is those good trees, good vigorous trees were as productive as the UCB1 seedling. You just have to remember the limitations of each variety so that you can choose the rootstock that you want that best suits the needs of your system and your orchard. With that, I jokingly call this talk Rootstocks Demystified. I'm certainly available to ask any questions. And please feel free to save your questions for our question and answer session.
Thank you, Elizabeth. And I don't see any questions on my end. So we have a break and we'll be back at 10:30. So hello, everyone. Welcome back. Our next presenter is Bob Beatty, Emeritus UC Cooperative Extension Advisor for Kings County. Bob will be talking about budding, planting, and young tree training. Thank you, Bob, and you can start whenever you're ready.
Okay, can everyone hear me?
Yes.
Wonderful. First, I want to thank the Pistachio Short Course Committee for including me in this year's short course. And I also am very grateful to have a chance to share with you my experiences with this subject. This will probably be my last presentation for the short course, since we have lots of young people coming on board that will have new information to share, as well as the historic information. I wanted to also extend my welcome to Douglas Amaral, who's the new farm advisor for orchard crops in Kings and Tulare counties. And we're looking forward to Doug's contribution to the pistachio industry. Get going here. Now it won't advance. Oh, there we go. Successful farmers know what to do, how to do it, when to do it, and then they do it. I saw this little comment tacked up on the wall of Sid Kite's office back when I started as a farm advisor in 1978, and it has remained with me as a very critical component of successful agriculture. And the components are not to be overlooked, especially when you're developing a new orchard. Another reminder for all of us is that we don't know what we don't know. So if you think you don't know, ask. And this is not supposed to be a tongue twister. This is supposed to be a serious assessment of you thinking about how much you really know about what you're going to do. And the most difficult thing in life is knowing what questions to ask. And I learned this from going to UC Davis, that many a professor kept looking at me and saying, Bob, you're not asking the right question. And so that's another very important aspect of developing a new orchard. So from about $11,000 an acre, you're going to start off with some type of plant material and turn it into a beautiful, well-canopied orchard. And your objective is to have 80% shaded area based on the work that has been done with other nut crops, and to have uniformity. And you've had several people, including Craig Carlson, who did a fantastic job with his design and also his cultivar talks, talk about the necessity of uniformity. And so part of this is rootstock related. The other part of it, or the very large part of it, is the soil types and your cultural practices to achieve this goal. Uniformity is where the money is. Craig has already done a great job of outlining the critical aspects of designing the orchard. You can review this on your own, but again, we always point out these very formidable objects like telephone poles, because there have been serious accidents that have occurred from poles being hit, power lines knocked down, and not only the risk of life, but also the expense that PG&E or Southern Cal Edison charges you to reestablish those. When you first, another key element that I want to start off and remind you of is when you lay out your drip line before you plant, get it laid out early, let it relax, and leave about 6 inches of drip line between the trees. And this is very important because that drip line is going to walk on you during the growing season as it gets warm and cold. And the emitter, which must, I repeat, must remain at the base of the tree in order to get this uniformity we desire, it will start walking away from the tree, and you will now have lost your opportunity to achieve this uniform growth. So leave slack in the lines. Talked a little bit about timing. Timing is critical. You want to have a plan, and you want to follow it, and you want to vet your plan with the experienced pistachio producers to be sure that you have not forgotten an important question to ask. And certainly execution is critical. We've talked about the drip line, but here's an example where this grower did not leave any slack in the drip line, also planted on berms. The infiltration rate of the soil was not taken into consideration, so the water is running off of the berm and not going to the root ball, which you're initially farming for at least the first 3 weeks of establishment. The trees were also mishandled and grabbed by the trunks and jerked around, in my professional opinion. That plus the lack of water caused budded trees planted in season to die, and now you have a non-uniform orchard, plus the cost and of replacing the dead trees and having them now be out of sync. And you're going to see that having the trees all in sync is a very important aspect of producing an orchard at minimal cost. So let's take a look at the planting stock. Elizabeth Fishner did a beautiful job of freshly reviewing the type of rootstock we have available, but it comes in different planting styles. We have our standard unbudded rootstock in a 6 mil plastic sleeve. This is kind of traditional. And although it could be clonally propagated material, most clonal plants don't go this far in the nursery. They're planted at smaller stages. Instead, it's typically produced from seed of known parentage. And then you have clonal rootstock, almost exclusively of UCB1 parentage. And as Elizabeth pointed out, she has taught you that that both UCB1 and PG2 have the same parents, but they are reversed in their role in creating the seedlings. And from these PG1 seedlings, there has been a selection of one of those that's now been clonally propagated for its verticillium resistance and vigor, which is now called platinum. And it comes, these clonal stalks come in various sizes, you will see, anywhere from 3 inches to all the way up to 48 or taller inches. You also have pre-budded rootstock with whatever scion stock combination you desire. And as I've mentioned, plants come in all kinds of pot designs and sizes, which are often proprietary to the nursery. There has been no UC research as of yet to assess the establishment superiority between any of these pot designs or plant material. And my mention of specific nurseries obviously does not constitute an endorsement. So here is our traditional plant material that's planted in a 6-inch by 15-inch, 6-inch diameter by 15-inch tall vinyl sleeve, about 5 to 6 mils in thickness. And these are typically used for seedling trees because the seedling trees are planted early in the season in the nursery and grown throughout the entire year. And in so doing, they wind up being very tall and vigorous trees that have a lot of robustness and tolerance for farmer abuse when they go when they're planted in the field. That sleeve is typically cut on the side in order to obviously remove the sleeve from the tree. And you should check with your nursery on this older recommendation, but typically there's a mat of roots at the base of these pots. And we have traditionally taken a machete knife or a very sharp shovel and cut off about 1 inch of this bottom pot because of this root mass tending to not be as viable. And also we want roots to grow radially from this root ball. Again, Elizabeth has covered clonal propagation starting from these axial meristems. And my point here is to have you think about this sea of clonal plant material or seedlings that a nursery person has to manage in the nursery and do so uniformly across all this area. So all these trees have to be as uniformly irrigated and fertilized as possible in order to minimize any problems with the young plant material. Now these clonal plants, unlike the seedling trees, they come in a wide range of pots. We have what we call these air pots that have slats on the sides. The theory being, and it has been tested by the arborists, and this theory is that the roots will grow out to the sides of these pots, and then the roots are then root pruned, and in doing so, you get a more radial root development, and also helps to minimize any danger in saturating this potting soil. Here's another very common pot, one that has been also successfully used. They're typically 4 by 4 by 7 to 9.5 inches tall, and this pot has been used for many years. However, the root mass that can result from the closed pot, depending upon the age of the tree, how long you've grown it in the nursery, can be rather dense. And that prompted one individual who's a very accomplished arborist, Brian Kemp, who worked with Corky Anderson at Pioneer Gold Nursery, to apply some of his tremendous arborist skills into the commercial pistachio industry. And he came up with a different style of aired pot, which I have nicknamed the Kemp pot. And this system is also being used as a way of providing these aerial roots for less danger of saturated pot soils. These pots come in different sizes, and here's a small tree that could easily be machine planted. However, these pots have to have a pin pulled, and all of this potting material, or the pot itself, has to then somehow be recycled, which can be problematic for some growers. But you see that here's the theme of this pot, is that you wind up with roots that look quite healthy, and according to the arborist data, this results in a more radial root system in the field, which of course is advantageous. There's also the beauty of these clonal plants. They can come in smaller sizes, and here you have a planting system that one nursery has developed that's been very successful, where you then take these trays out into the field, and you have 1, 2, 3, 4, 5, 6 by 2. You have 12 trees in this tray that you could then distribute out into the field or on a planting machine and plant readily. But I want to make this point very, very clear. When you plant trees out of the nursery that are in full leaf, you have to realize how tender they are, and you have to take tender management practices to ensure that they're successful. We all understand and agree that pistachios are pretty tough, but there is a limit, and the more careful you handle these plants, the more readily they become established, and the more uniform they're going to grow, so that you can achieve a 95% or greater bud take in mid-July. Here's another very fascinating system that's been developed by Sierra Gold Nurseries. It's called the Elipot, and this system leaves the plastic at the nursery, and they have a gauze, a biodegradable gauze that goes around the plants, and not all of the trees are this big. They have them in different sizes, but this gauze then allows, there's a gap between this gauze and the plastic pot in the nursery, which achieves the air root pruning technique that has been described earlier. And so these roots are also healthy, and they then depending on tree size, they then take these trees and put them in these plastic containers, say 6 trees to a plastic bag, and deliver them to the grower for ease of planting, machine, or by hand. Now, as I mentioned earlier, this tenderness of the plant material, this is plant material that can also be successfully grown, but I would be inclined with tender material like this to plant it early in the season. I am fully aware of the fact that growers are planting up into June because of lateness of ground preparation, but I'm wanting to, I personally do not encourage that, and I'm going to be explaining to you why. I prefer myself to actually take plant material, take receipt of plant material from the nursery in the dormant stage rather than it having already started to be leafing out, and then cut the plant material at 24 inches. So I have a dormant, manageable tree that I can then handle in the late January to March period and get it established in the ground before the tree initiates its grand period of growth. And this is a pomological principle that needs to be taken seriously because deciduous trees go dormant. And then when they begin to wake up in the spring, they have a very rapid growth period. And during this growth period, their roots are expanding out into the soil. And so by taking advantage of this rate of growth from the emergence of dormancy, you allow these plants to hook up in weather conditions that are far more favorable than planting in late spring when the temperatures are much higher and put the plants under much greater stress. Budded trees are also is an excellent plant material. They're hard to come by at times because they are in such high demand as replants for established orchards. They are typically put in the 6-inch poly liners. And I believe that these are excellent plants to be considered for fall planting. And when I say fall planting, I'm talking about maybe September 1 to the no later than the 15th of September, rather than Halloween time, which I am actually seeing people testing fate this year and putting plants in that late due to the risk of potential freeze. But these plants have already achieved the 42 to 44 inch height. And so planting them in early fall allows them to get established. And then you can cut the water off and heal them up and get them brown, get the cyan tolerant for the upcoming freeze. And then you can head them off at 42 inches and be ready to start your second year of training. So when should I plant? Well, as I mentioned, late winter to early spring is my preferred time, just as in my professional opinion. I defend it based on the pomological principles of the grand period of growth and root initiation. I prefer early February to late March for rootstocks only. You could plant budded trees once the threat of frost is passed, and I wouldn't put budded trees out in the spring until I knew that I was past the frost period. Late spring to early summer, which would be mid-May to mid-June, in my opinion, is a poor time to plant. Now I'm going to, again, I wish I had more time to defend all of my horticultural opinions. You're going to see that most of this talk is based on horticultural opinion because we don't have UC research data to support all these statements. But what you've missed is the grand period of growth. The plants will go into immediate stress, even if you take the best care of them. And it's highly unlikely that the plants will be large enough to get a high bud take. So you have failed to achieve the first year objective of scion growth to the top of the stake for dormant heading to 42 to 44 inches for the vase training method. And I will make some comments about the central leader system, although I've been asked to limit them due to both time and the fact that there are researchers actually developing data to compare that system to the standard vase vase shape method. Fall planting only makes sense to me if you plant budded trees close to a 48 inch tall, no later than say September 1. Again, pomologically, this gives about 5 weeks to get them hooked up into the native soil before you have to cut the water off by October 7 or so to harden them off and prevent loss to freezing temperatures that typically occur between November 15 and 25. Now, can you plant rootstock on October 1? Yes, you can plant rootstock on October 1. There are people planting rootstock right now, which is October 31. The risk you take is that a sudden hard freeze could damage that material, and you then have to have bud material soon enough in the springtime. Once those trees reach at minimum 3/8 inch diameter, you then have to have dormant budwood available of small enough size in order to bud those trees early enough to take advantage of the fall planting, so that the next full growing season you achieve the scion up to the top of the tree. So this is why I'm not a big fan of fall planting pistachios. It's completely different with almonds. I'm a fan of planting almonds in the fall. I'm not a fan of planting pistachio rootstock in the fall. Here's why. Late planting, you don't maximize the plant growth and you delay development. So here's the trees that are planted on time, done early, and they're up the stake at the end of the season. And here are the trees that were planted late in mid-June or late mid-May to June, and they're just now developing their science. There's a host of different stakes that you can use to plant pistachio trees, and here we have a metal stake, and I just point out that we want to have the dip towards the tree in order to train the tree up. 4x4 wooden, 2x2 wooden stakes are also used, but you want to be sure and get a full 2x2 stake, and you have to watch the knots in these wooden stakes because the quality of the stakes varies greatly, and if you get knots on them, they will break, and you'll be constantly replacing stakes in windy areas. There's also metal T stakes I've seen used, and the T portion of the stake is pointed away from the tree. Another key point is do not get your planting material spread out too far ahead of the planting crew, because especially if it's a warm day, those black pots get hot and it puts those trees under stress. Another reason why I like to plant dormant trees, because the leaves aren't sucking the water out of the root ball, and I do not want plant material left in the field at the end of the day. I want all the plant material at the farmer's site where they can water it back down and start fresh. Leaving the pots all day long in the field is another reason to have stressed trees that don't grow as uniformly. I know that this has now become somewhat of a joke, but I'm not going to give up on my insistence that the planting crews handle the trees properly. You don't reach in there with your hand and grab the tree at the neck of the base of the tree and yank it out of the bin, because it's been packed in there such that when you try to yank it out, you've now disturbed the crown of the tree. That's not a sound method of handling baby trees. They should be handled by the edge of the sleeves, and depending on how big the trees are, so you don't drop them, you put your hand under the bottom. But you don't want to disturb the root ball. You do not want to disturb the root ball. You want the root ball to be as intact as possible when you put it in the ground, so that the tree does not suffer stress conditions that prevent it from hooking up and growing vigorously. This is the preferred planting tool, a balling shovel. You can also use clamshell diggers, and I've also had people obviously use machine planting as well as small drills on the back of the small tractors. Be sure and not get treated soil into the planting hole because it will limit root growth. This is an old recommendation that still stands. Don't plant in too wet a soil because you're going to slicken the sides of this soil, especially in some of the heavy ground that we're now planting in. And these slickened sides will create basically a clay pot that will make the roots very difficult to penetrate into the soil. Also, don't plant your trees too deeply. We want to plant them just low enough so that we can get some of this native soil on top of this dark soil, because it will heat up during the daytime and try to dry out some of these crown roots. We want to also be sure if it has a bamboo stake in it that you cave that in, because that's an area for water loss. And depending on the size of your planting and the time that you planted and the heat that you planted into, I'm a big fan of building some type of a basin around the trees. I know growers that are planting sections, again, they laugh at this, but this basin ensures that the water is going into the root ball. Another key element, you have to be sure the water goes into the root ball, because you're farming the root ball for the first 3 weeks. And I'm going to show you how to manage the moisture in the root ball. ET is of no value on baby trees. You have to get out there and get on your knees and dig around and see what you have every week, if not twice a week. Also, you can put the pot on the top in order to facilitate its being collected. Now, this grower has successfully put the emitter next to the base of the tree, but now the question is, how much of the applied water is the root ball seeing? And that's one of the reasons why I like the basin technique. I know where the water is going. Here's another method to help improve application uniformity, which is what we call the pecker. And this is a ½ gallon or 1 gallon an hour emitter with a little spaghetti tube, obviously, that is right in the root ball. And this then allows the moisture to penetrate into the root ball, but you don't know how much water is going into the root ball unless you check. If you have micro sprinklers, perhaps your variable drive system can be turned down low enough so that these are now turned into dribblers. Or you could come up with a hat system and cut up a piece of larger size PVC tubing, drip tubing, to put over the top of them so that when you irrigate, the water goes right into the root ball. Notice here with this micro sprinkler, all of this wetted area that not only eliminates uniformity, not only creates uniformity problems, but also creates weed issues. You would think that this soil is super wet, but notice here that the grower actually delayed irrigating until the top of the soil got too dry. The meter says that the root ball is still dry. And the way to check that is to get your trowel out. And twice a week, I go out and I dig next to the root ball and I stick my finger, I call it the pomology proctology test. And I put my finger in the root ball and I'm checking that moisture. And that way I know that I'm not getting those roots too wet, because this is a healthy root system. And this is the problems that occur from overwatering baby trees. You waterlog the soil, these roots turn black. They're then susceptible to Phytophthora niederhauseri, which is a new Phytophthora that Flo will be teaching you about. And when the roots get black like this, the trees start to turn yellow, they don't grow. And now you have a uniformity problem, and your $11,000 per acre to the 6th leaf is now going to go to $12,000 an acre. Corrugated plastic sleeves or cartons are routinely placed around trees because of the requirements for herbicide management. Here's another technique that I like. See the berm that this grower has elected to plant? They wisely then drug a little furrow maker over the top before they planted to create this divot. and then they put their double line drip system in that divot. So when they water, the water stays in that divot. That's also a good way of spreading gypsum in case you have an infiltration problem. Unfortunately, this grower didn't ask the question about how many weeds they had in the field prior to planting. And now they have a huge mess, which not only creates problems for water use, but also varmints such as voles and gophers can attack these baby trees. This is what you want to have occurring in the trees. This maroon growth, this tells you that things are growing vigorously. I wish that we had time to discuss the details of managing these growing tips. But typically, if I get multiple growing tips at the top, and depending on how vigorous the trees are, and I may actually come through and pinch some of these off in order to have the most vigorous one grow up the stake, so I have a nice clean spot to bud. So let's talk about the time of budding. The time of budding is dependent upon rootstock vigor, planting date, and the availability of budwood and the availability of the budder. Stock planted from January to early April should be at least 3/8 and more like a 1/2 inch by mid-July to early August, depending upon when you planted it and the original plant size and the cultural practices. Don't push your budding too early. You're better off to have a little bigger tree, closer to 1/2 inch, in order to get a good bud take, especially with Golden Hills. Craig has taught you that the shield on Golden Hills is bigger. So you want to have a little bigger tree. And then when you put that bud into the tree, why it pushes better, and you wind up with more uniform growth and higher vigor to achieve the scion all the way up the top of the stake for their first growing season. I've talked about the larger budwood in Golden Hills and the shield, and thus the tree needs to be a little bigger. You want to communicate with your budder to let him know how you're doing. Now, I repeat this. You want to be talking to your budder regularly, because these budders are now covering thousands of acres and they don't know what your situation is. So by calling and telling them how things are going, texting them some pictures, goes a long ways to help them start putting you into the loop, so to speak, because when they get into your area, they'll then know that they can pop over and take care of your ranch because it's of sufficient size. Be careful about pushing the bud when budding after the first week in September. Early frost in November can kill that little tender scion shoot, and you will have lost a lot for very little gain. Pistachios can be budded in September, but don't force the bud. Don't cut the tree back. Instead, allow the tree to go dormant. Even if the bud remains dormant in the scion, you can grow it out in the spring. And one technique to encourage the bud to grow in the spring, if it seems to be slow to emerge, is to take your knife and do a little knife girdle over the top of the bud. And this will help accumulate auxins and other plant growth regulators to get the bud to grow. And that's what happens to late budded trees that are pushed. Just fried the scion, and in this case, damaged the rootstock to the point where we're going to have to start over in the springtime. Here we have our beloved Carl Finucchi next to a very vigorous rootstock. You can see that it's over 1/2 inches in diameter, and this is where the use of dormant buds comes into play. There's several nursery propagators have been collecting dormant wood of the desired cultivars and storing it carefully, and they're then prepared to not only bud replant trees, but also early fall planted trees that reach heights of this size in May. As soon as the trees begin to slip, they can then insert a dormant bud, which then allows you more time for developing the desired scion after budding. Craig's also mentioned this, but I'm going to repeat it, and that is sometimes the poor take on, or the lower take on orchards has to do with immature buds that were selected. And Craig's pointed out that in Golden Hills, there are fewer good buds on a bud stick than there might be on Kerman. So you have to look at, when the budders are budding, they try to avoid these buds on the tips of the scion, on the tips of the selected bud stick, because they oftentimes are not mature enough. And so when you put them in the tree, they then don't grow. We're budding at 28 to 32 inches to get above where the shaker occurs. And you don't want to have that bud union, as Craig pointed out. This can't be down in here, because when the shaker grabs it, it's going to tear the tree up, and that now causes less growth in your beloved pistachio tree. And although pistachios are not as susceptible to wound cankers like almond, they heal very slowly, and excessive damage weakens the tree. Okay, let's just see how fast these budders are. Here's a bud stick, and here is the budder, and watch him successfully bud a tree in 15 seconds. So that shows how the budder buds it. Here's what you wind up with. They make this T-bud that Elizabeth described. They insert the shield, and this bud typically takes about 14 days before it begins to push. The budding rubber will disintegrate, say, in about 10 or 12 days. We noticed this year, for example, that the rubber wasn't as good. Had budders having to come back and retie trees because the rubbers were disintegrating in 5 days. That's something you want to pay attention to. We, in the past, have used a 24-tooth hacksaw blade to actually cut above the bud in order to encourage its growth. And with Golden Hills and the newer varieties, that doesn't seem to be as necessary. But about 5 to 7 days after the tree has been budded, we do come back in and we remove, by performing tipping cuts, removal of a portion of an existing limb. We perform tipping cuts over 50% of the growth to just remove the apical dominance, or the meristems of the rootstock, in order to favor the development of the rootstock. And late trees that are missed on the first round, you could actually train the rootstock up and head it at 42 to 44 inches to develop lateral branches that could be scaffold budded to help improve uniformity. So here's the goal of the first season. We want to have rootstock that's been planted and grown uniformly. We train the sign up the stake, and beautiful trees, but then we're going to shut the water off in time to harden off and this tender shoot to prevent freeze injury. We know that these hardened trees offer more tolerant of cold injury. They actually, Dr. Z, one of our professors at Davis, has now documented that there's a burst in respiration that helps serve to avoid injury to the plant with trees that are properly hardened off versus those that are not. So why train and prune pistachio trees? Well, we train to increase their vigor or rate of growth, not the total growth. An unpruned tree will always be bigger than a pruned tree, but what we're attempting to do is to direct growth in a desirable location for the purpose of developing a canopy that is intercepting large, efficient light. We're farming an acre of light, as Craig pointed out. We want to create a strong framework for large crop loads, this light interceptor concept. We want to induce desired branching where we need it. We want to stimulate new fruit wood. Pruning can also mitigate alternate bearing, which Louise will be talking about. And very important is to facilitate harvest and cultural operations. And I'm going to just show you here quickly Here's the harvester. Notice where the lower branches are relative to the shaker frame. So that points out the necessity of having a trunk that's high enough so that the catch frame, the receiver, and the shaker can harvest without tearing those lower branches off. So let's look at the pistachio growth characteristics. They're moderately vigorous, and actually the vigor has greatly improved with the interspecific hybrids, with the platinum and the UCB1 parentage. Why, we've gone a long ways from Atlantica, and that allows us some greater opportunities to consider the central leader system. There's two main flushes of growth, one in the spring and the summer. They grow largely from terminal buds. Spurs are neoform growth of 7 to 9 nodes, and they occur laterally on 1-year-old wood. These spurs are critical for fruit production later on in the tree's life. They don't grow in diameter as rapidly as other deciduous nut trees, and this results in the potential for flat structural branches and an excessively open tree center. And with the vase system, we're attempting to have the tree be compressed and fairly upright in its youthfulness, because the bearing habit of the tree is that the fruit is borne close to the terminals. It's very apically dominant. So everything happens on the ends of the shoots. The growth typically happens on the ends. The fruiting happens towards the ends. And consequently, this creates a cantilever effect where the trees are constantly being, the limbs are being forced lower and lower. And so it's important to then start with a compressed upright structure. Here's an example of this apical dominance. I saw an orchard this year that didn't get pruned. And here's a 1-year-old tree with a poodle tail on top, and there's no lateral branching. If this were an almond tree or a peach tree, you'd have limbs all over here, but such is not the case with pistachio. Here are older branches showing the apical dominance. And notice this shoot grew this long in one season, and then it forced some lateral spurs, those preformed shoots, but there's very little lateral shoot development as you would see on an almond tree. And it is for this reason that we typically over prune pistachios in order to force lateral branching at the desired locations, to have a compressed canopy for efficient fruit production. Now, I told you I'd mention the central leader system, which is one that is not uncommon to pomology. However, it is the concept of using central leader was tried by one of our Carl Opitz, an old-time extension specialist originally from Tulare County at Kearney, and he abandoned the central leader system early in his investigations. However, he was working on Atlantica, which is a weak rootstock compared to our interspecific hybrids. And Brian Kemp, the arborist that I mentioned to you, very accomplished arborist, in conjunction with Jeb Hedrick, they met with me back in 2007 to discuss this central leader, but I was tied up in so many other research projects that I wasn't able to actually start an experiment with this. This is fortunately now being done by May Columbar, Elizabeth Fishner, Catherine Pope, under the direction and leadership of Bruce Lampinen. And so we'll get a chance to see whether with the high-powered rootstocks, the central leader system works. They grow the tree unheaded the first growing season, and then they typically headed about 60 inches. And then they get these lateral branches that grow the season. And my understanding is that there's no in-season pruning. These are then dormant pruned. And my concern is this, the flatness of the resulting primary branches. But again, the trees are pruned less, and being pruned less means that they bear more crop earlier. And here's a nicer central leader tree. And here was the original trunk that was headed high. And then these branches actually grew more upright, which makes it more conducive to leaving these lower branches. And here's a 4-year-old central leader tree that also has more upright branches. So they vary a lot in their character, but the concept here is to prune the tree less during the early years so that this curve has greater yield in the early years. And then as it reaches maturity, the question is whether or not, once you've reached 80% shaded area, whether the yield potential is any different than a vase-shaped tree. And my discussions with Bruce Lampinen as initially thought that once you reach 80% shaded area, that you're intercepting maximum light. And so the bearing potential, because we haven't improved the fruiting efficiency at maturity. Now we've improved the canopy size, meaning that we have more fruit wood early, but at full maturity, we're thinking that the trees should bear about the same. Time will tell. So developing pistachios for the first season, as I mentioned, we want to develop a vigorous rootstock for budding. Then we want to bud it in time to get this 36 inches or greater of scion growth. And they can grow as much as 1 inch a day. I do not advise heading the scion during the growing season, even if it gets to be 6 or 7 feet tall, because you have cost yourself carbohydrates for the fall, and there's nothing to gain. You're far better off to let that scion grow dormant and perform a dormant heading cut, get the tree nice and stored up with carbohydrates, get the girth of the tree better, because if you cut it in season, the scion as it trains up the stake, if you cut it in season, it's going to have more taper to it. So far better off to dormant head the scion in the first winter. Missed buds, or you bud missed trees immediately, but don't force them after the end of August. And then, as I've mentioned, winter prune the scion to 42 to 44 inches in the vase shape system, but no lower than 38 inches. Once the bud begins to grow, we need to get a tie on it quickly so that the scion is straight. Otherwise, this scion can come out and get a hardened portion of tissue that if you try to bend it up, you'll break it out. Here's a tree that has had regular passes made during the after budding. All of this growth occurred the first growing season on a tree that has been planted at the right time and budded promptly. All of this has occurred the first growing season, which now allows you to head it at 42 to 44 inches. Another example of a beautiful orchard approaching fall that's been properly hardened off, weed control under excellent conditions, and plenty of growth for heading. And even though they grew so well, no value, in my opinion, in heading them in season. We then head these, as I mentioned, at 42 to 44 inches in the wintertime. We also leave a portion of the rootstock above the bud union, because this can die back, and we don't want it to die back into this area and weaken the union. Goals for the second season: develop 2 to 4 primary and secondary scaffolds. We want to tip those primaries and secondaries when they reach 12 to 14 inches to force lateral branching. This may seem severe, and it is, because we're attempting to have those primaries and secondaries with sufficient uprightness to maintain a tight tree when it's young, so that as it gets older and lays out, we have those structural branches that maintain that upright nature. The last tipping date is for these primaries and secondaries, which I'm going to show you, is dependent upon plant vigor and growing location. Kern County goes as late as mid-August, but in most of the areas that I have visited and helped growers, we need to be done with tipping no later than mid-July. There's also a process of pinching the leaf off the petiole at the second and third node positions, which I'll show you, which supposedly encourages more lateral growth. That hasn't been tested. It'd be a fun project. We cross tie the tree as needed to improve upright tree shape, and we prevent nutritional deficiencies. Then they stop tree growth, and then we winter prune secondaries, prune the secondaries to 12 to 14 inches, tertiaries at say 22 inches. On Kerman, on Golden Hills, we prune those tertiaries to 18 inches because they don't branch as well. Now, let me just say that the second growing season is a critical season for pistachios because you are attempting to get primaries and secondaries developed, and I'll show you that attempting to get tertiaries is not advised. Here's a tree that has not had the primary growth converted into secondary branching, and this may be because this orchard appears to be being converted over to a central leader system, but we would typically head these primary branches at 12 to 14 inches, and we attempt to have the lateral buds be what I call tangential to this axis of the stick. You don't want to be tipping to a bud that's going radially, or because it then causes the tree to spread too quickly. You want the tree to be growing upward. Here's the pinching technique, and here is the secondary. Here's the primary bud. Remember Craig telling you, look down in there on the Golden Hills and make sure there's a bud there. Don't tip it if there's at the location if there's not a bud in looking at you in the axil of the leaf. And here we've had the leaf petiole clipped off with the theory that it helps promote the development of the secondary of this bud development. Here is what I was pointing out earlier. Here, this has been tipped, and this branch is now growing out this way. We would much prefer that this branch is going this way, and this branch is coming towards the screen. Here is waiting too long to tip. And if you wait this long to start tipping, you then delay this lateral bud development. And if you wait too long and tip, these lateral buds can oftentimes not grow at all. They'll sit there for 3-4 weeks before they finally begin to push some growth, and now you've lost precious time. And if you also tip too late, you oftentimes only wind up with a single shoot. Two scaffold trees are very productive trees. I tend to be sure to head these two scaffolds a little harder, maybe 12 inches, in order to fill this space that is left void by not having enough scaffolds. We oftentimes on Golden Hills now have at least 3 and oftentimes 4 primary scaffolds on Golden Hills. Here's the 2 scaffold tree that was headed a little taller than I would like, but you can see that the position on 2 scaffold trees of these buds is really important, because you want the tree to be filling this space by this scaffold and this scaffold. You don't want the limb to be going out some direction that doesn't help keep the canopy compressed. Craig's already pointed out the smiley faces that can occur with 2 scaffold trees and the necessity for bolting them. Here is a tree where the grower has attempted to get tertiaries in the second growing season. He got primary branches, he tipped, he got secondary branches, and now he tipped because he thought he had enough vigor to get tertiary branches, the third tier. And this is risky business. It's not advised in almost all pistachio plantings because you wind up with what we call the Mickey Mouse ears. And now you have these tertiary shoots that haven't grown enough to do anything with. You either have to leave them and let the terminal bud grow in season so that you can then in season tip it. Many times the pruners, when they come in and see this, they'll just cut the whole thing off and start the tree over, which now increases the over pruning of the pistachio tree. So our recommendation is to not attempt to get tertiaries in the second growing season. Watch out for nutrient deficiencies. Here's typical copper deficiency, where you get clover leaves and then you wind up midsummer with these shepherd hooks that develop and the shoot is dying. And people think that they have a disease problem when in fact, this is copper deficiency. Here's also zinc deficiency. These deficiencies are very common in the second year because we've over pruned the trees and we also have a limited root mass for nutrient absorption. So foliar sprays are typically in order, and growers will put on at least 2 and sometimes even 3 foliar sprays as an insurance program against these deficiencies that limit canopy development and orchard uniformity. False chinch bug is one I have to point out to you. If you have weeds in the field as the trees are growing up in the first or second season, these false chinch bug will get up in such great numbers, they will feed on the tree, emit a toxin, and actually kill the tree. So you can read here about some of the weeds that are very commonly associated with false chinch bug. But this spotted spurge that lots of people let go because it's such a prostrate weed becomes very problematic. Or if you planted a cover crop, you planted barley in the field and you want to, or wheat, and you're going to cut the wheat, make a little money. As soon as you cut that wheat, you better be watching for false chinch bug coming onto your trees. Gophers. You cannot tolerate gophers in pistachios. They kill pistachio trees, and they will kill pistachio trees up easily until the 5th, 6th year. Tying young trees turn poorly shaped trees from what I call mutts into kennel club champions. The challenge is keeping the pruners from getting too creative with this because you can burn up a lot of money with tying or spreading. But here's a tree that's been beautifully tied to create this primary and secondary branching in the second growing season. And here the tree was a little too tight, and so the pruner created a spreader. Do not put the upper tie tape around the lateral branches. The tie tape grows into these before you know it, and then you've now created potential limb breakage. This is the location for the upper tie. And after the second growing season, you want to be sure to tie the tree securely to the stake. Here is a classic example of a nice pistachio tree that has been well tied below the crotch of the tree. Now here you see it's often difficult to leave more than 4 primary scaffolds because there's not enough room in the circle. And I could spend 15 minutes describing this tree to you, but I just want to point out the difficulty of the pruner. If this limb is not coming towards us, but is truly in the center of the tree, then you say, well, okay, that needs to go. I'm going to save this one, and this one. Now what am I going to do with these 3? Well, you can't keep these 2 because they're too close together. You can't keep those 2 because they're too close together. And this one is straight up. So you say, well, this has got to go. Well, then this one may be too low and it's going to get torn off by the catch frame on the receiver or the shaker. So typically I'd say this one goes. This one is certainly a save. And if this one's in the center of the tree, then you have to take 2 primary branches off and wind up with 1, 2, 3, 4 primary branches. And again, another example where we talk about limb number 1 has to go, Number 2 is upright due to its position. Number 4 could be kept if it's not in the center of the tree, but you certainly have to keep number 3 because it's facing into the wind. You'd never cut out the limb if you can avoid it that's facing into the wind. Second year tree with good distribution. Here we can see 1, 2, 3, 4 scaffold branches. Here you see having too many lower scaffold branches that has resulted in the choking out of the upper limbs. So you have to prune to vigor. Pruning all these off to go to these weaker limbs is not a good idea, even though they're in better positions. Goals for the third season, need to cross tie the main branches, maximize growth of the tertiaries. We don't tip the tertiaries in the third growing season. Let the tertiaries grow, let the tree recover on the vase-shaped system from the heavy pruning that you performed in the second growing season. This gets the tree nice and strong for early fruit development. Prevent nutritional deficiencies, and then winter prune those tertiaries 18 to 22 inches and avoid knuckle cuts, which I'm going to show you. Here's the untipped tertiaries. And you think, gee, I'm wasting all this growth, but you're actually investing in your future. And nice upright limbs that are nice and strong. Now here's a tree I'm going to show you, these night shots that I took, that shows that I tried to get greedy and get those tertiary branches. And if you study this tree, you'll see that there's a lot of poor branching. I got secondaries. Here I got good tertiary development, but here and here and here I got poor lateral, poor branching. So it wasn't worth it. Typical points to make in pruning: avoid tipping all the vegetated buds off, which can happen. You're going to wind up with fruiting that will occur in older trees. Here's a flower bud, and there's a vegetated bud. You have to have at least 2 of these or more above your flower bud. Don't prune trees late, like Craig said. And also prune 3 to 4 buds above the growth ring. Here's the growth ring. And you do not want to perform what we call a knuckle cut, which creates this kind of growth on your structural branches. Here's a structural branch that got knuckle cutted. You have multiple shoots that all wind up becoming spurs, and you've now lost the development of your structure. Also, I've mentioned to you about positioning these tipping cuts so that you avoid this radius type of cut. Instead, you want it to look like this to properly fill the canopy. And there are times when you have to long prune trees, even though they look ugly, and maybe perform more tying because you have saline conditions, and the harder you prune this tree, the smaller the tree is, and you never get into production. We're almost done here. So we minimize the thinning cuts to improve early for the 4th and 5th growing season. We don't do a lot of thinning cuts now because we don't want to over prune the tree. That's removing an entire branch from its point of origin. Instead, we're performing heading cuts to principally just to shape the tree. We winter prune current season's growth about in half, optimize the nutrition again, and avoid late season irrigation to prevent the tender current season's growth from getting frost injury. So there is your goal. There's a pistachio tree ready to make money. Look at all of these preformed spurs. That's where the money is. The money's not out here. This is future money, where you're developing your canopy to have 80% shaded area. This is a beautifully shaped, vase-shaped tree that has lots of spurs and ready to help do what successful growers do. And that is, they know what to do, they know how to do it, they know when to do it, and then most importantly, they do it. Thank you very much.
Thank you very much. Doug is going to proctor some questions to you, Bob, but before he does that, I know we ran a little bit over, and in the interest of everybody's time, I really want to be respectful of that. So I think we can stay on for another 10 minutes or so answering questions, but I did want to put up the the information for next meeting so that we can, if you do need to leave, you can. So first of all, I just want to make sure you can see that our next meeting is on Monday, starts at 8 a.m. And then we have the rest of the events. And then here is that QR code for the Certified Crop Advisor. You can search on the App Store for California Certified Crop Advisor, and you should be able to scan and just get your points. If you don't have the app, no problem. Email ANR program support, and I'll put that email in the chat. Also for the Coalition for Urban Rural Environmental Stewardship credit, just email me saying that you're interested in getting those credits if you have if you're able to get those credits, and I will contact you for other information. Also, there's an evaluation. I've just dropped that into the chat. If you could fill that out, that would be great. And yeah, I'll leave this up while Bob answers some questions.
Thank you, Bob, for the excellent talk. We got a few questions for you. And Kelly, can I share my screen with Bob so he can read the questions as well?
I called up the Q&A, Douglas, and it looks like I may be able to see them here.
Yeah, I kind of organized them on a Word document.
Let's see, what's the first one, Douglas?
First one is, if you have to replant, should you plant male or female to maintain orchard uniformity?
Okay, so if you have to, could you repeat that question again?
If you have to replant, should you replant a male or female to maintain orchard uniformity?
Well, the answer that I would give on that is, first of all, it depends on what died initially. I'm assuming that you're replanting trees that have been lost in the first growing season. So if you going to Craig's comment, if you planted your orchard with only a single male and you then discovered that maybe having a second male in your area would be to your advantage, and you lost a male tree from either a male or a female tree during the first growing season, this does allow you the opportunity to now insert, if you could find, ideally, if you found budded male trees of the desired cultivar, that you could then intersperse some second cultivar of male into your orchard in some of the replant areas. But you wouldn't want to get carried away with that. But it would allow you an opportunity to add some extra, a second male to the field. But if you have designed it such that you already have two males, then certainly maintain the integrity of your planting and replant the missing tree with the male or female that died.
And the second question is there a cutoff time to plant pre-budded replants in the field in Sacramento area?
In Sacramento area, certainly after heavy rainfall has subsided, and you can see that you have the potential for frost-free conditions. The old saying in the San Joaquin Valley is that you can be pretty much assured of having frost-free conditions after the third week in March. We had a 27-degree freeze on March 27th of 1972. So we typically would wait on the replants until the latter part of March, and then make sure that you put an emitter right at the base of the tree to ensure, and you may even have to tank those trees initially to take good care of them, while you're waiting to irrigate the larger trees, which may not be until the 1st of May.
And the next one is, what is your recommended irrigation rate for young, just planted trees?
Well, this is, as I mentioned, and I apologize to everybody for racing through my presentation. I put as much material in it as I could, thinking that it would be for posterity's sake, perhaps. But the answer to that question is, we toss ET out the window. We go get ourselves a trowel and some knee pads, and we go out in the field and we dig next to those trees, and we do the proctology test. And here's my slogan that I tell all of the growers that I have advised over the years. You can always add more water. So if you think that the trees are getting a little dry and you have a ½ gallon an hour emitters and you just put in your newly planted trees and you're feeling the root ball, okay, give them a 4 to 6 hour shot with your drip system. We're not flooding anymore. You don't have to call the ditch tender, and when you get water, you have to put on 4 to 5 inches. You give them 4 to 5 hours of water, which is only 2 to 2.5 gallons of water, but you're putting it right at the base of the tree. And then you go back after you've irrigated and you reassess the moisture in the root ball. And if you still think they're a little dry, then put on another 4 hours of water. And by doing that, you will quickly learn how much water those trees are using under your conditions, but it requires the growers to be out in the field with some method of assessing the root ball moisture until for at least the first 3 or 4 weeks, until those trees begin to hook up into the native soil. And as they hook up in the native soil, they then obviously have a much higher water content available to them, which reduces the necessity for light, frequent irrigations.
So the next question is, what is the difference between fruit bud and vegetative bud?
Well, obviously, a fruit bud has differentiated during the growing season into the capacity to create flowers that results in the fruit that we're hoping to harvest from the pistachio tree. A vegetative bud, in contrast, is only a bud that is capable of creating a new shoot. And so vegetative buds is synonymous with shoot buds, and flower buds is synonymous with fruit.
The next one is, when are new trees dormant? If early in, why not plant them rather than late January?
Okay, please repeat, Doug.
When are new trees dormant? If early in, why not plant them rather than late January?
Okay. This is an interesting question because it goes back to Phoebe's talk about the carbohydrates and how we're attempting to maximize carbohydrate accumulation in trees that we're developing under very rapid growth conditions the first growing season, or even in the second year when we're pruning them so hard and taking photosynthetic area off the tree. So in the fall, we hope to have trees that are sufficiently vigorous in the fall that we can justify, in my horticultural opinion, that we can justify putting on not only withholding water, and that starts anywhere depending on the location of your orchard and the soil type, anywhere from late August to very early September. In real sandy soil, you might go to, say, the 15th of September, but by withholding water in pistachio, we then begin to send the signal to the baby trees that the favorable growing conditions are starting to diminish. And in doing this, the tree then slows down its vegetative growth and converts vegetative terminal growth into growth in diameter. And as the tree slowly dries in soil water content, the wood, the bark of this tree, which is initially very green, it begins to brown. And as it browns, which we call lignification, as the bark lignifies, it then is hardier and more tolerant to cold conditions. And trees are not dormant until they no longer have an abundance of fully functional leaves. And by fully functional leaves, if you have a tree that is still nice and green and you go up to the tree and you tug on the leaves and the leaves don't fall off in your hand readily, those leaves are still functional. And the pomological thought, the leading thought is that those trees are not going to go into, they're not preparing for dormancy. They're still under growth stages. So under those conditions, we then put on baby trees. I still recommend putting zinc in fairly high concentrations on baby trees in order to slightly injure that leaf tissue and get some zinc into the cuticles and spot the leaves up a bit so that those leaves become, they begin to more readily senesce and abscise from the tree. Now, one might argue, well, gee, you're giving up carbohydrates, but the amount of in my opinion, the amount of carbohydrate that I'm sacrificing by defoliating a tree, a young tree, which, now pause and think of this, has already achieved my growth expectation for the season. I've already got what growth I need because I'm going to go in and cut this thing back to 18 inches and I probably have 48 inches of growth. So I've achieved my growth potential. What I'm more concerned about now is shutting this tree down and getting it into dormancy, especially if I'm now in the 5th or 6th year. I want to get those trees into dormancy quickly so I can maximize my chill portions. So allowing trees to not be zinced, in my opinion, in the fall, if you have an actively growing functional leaf canopy, to me, reduces the period in which chill begins to be accumulated.
I'm sharing my screen. Can you see the questions? Bob.
I'm sorry, Doug?
Can you see the questions on your screen? I'm sharing my screen with you.
Okay, let me see here. What is height? Oh, minimum height for budding? 28 inches. How to increase tree growth sideways? Well, we've tried things like growth regulators, promelin, for example, to get sideways growth. The only way that we have practically improved sideways growth is to perform heading cuts, which is the removal of a shoot, a portion of a shoot, so that and you cut it at the position where you want the desired side growth. 8, at the time of planting rootstock, do we head it? To what height? Well, boy, I'm sorry I'm so long-winded, but these questions have complexity to them. If you're planting rootstock early in the spring and you've taken delivery and it has growth at the tips, why, as you saw in that one slide, I go in and I cut it to 24 inches. Now, in doing so, I'm hoping that cutting it at 24 inches, I'm then planning on budding that tree in mid-July to current season's growth. Because from that 24-inch cut, I'm then going to now reinitiate lateral growth, and it's going to grow up, and I'm then going to bud current season's wood, which is at least 3/8 to 1/2 inch in diameter in mid-July to the 1st of August at 28 to 32 inches. And we did a little experiment this year where we headed trees versus we didn't head trees. And on the trees that we didn't head, we performed budding in the trunks. And this is referred to as trunk budding. Okay, what is trunk budding? Trunk budding is budding into last year's growth. So by not heading the tree and planting it tall and tying it to the top of the stake, we then allowed the tree to grow unpruned. And then we went in mid-July and we placed the bud at 28 to 32 inches in the growth that had occurred in the nursery, rather than the growth that we created from heading the tree at 24 inches at planting time, which then was budded at, well, into current growth. Douglas, does that make sense to you?
Yes, sorry, I was on mute.
Oh, okay. Okay, then can you comment on brown edged leaves at third leaf and suggest a solution? Okay, leaves that are brown on the edges are due to boron accumulation. So you need to go into your soil, do a soil analysis, see whether or not your boron levels are 3 parts per million or greater in the soil, and also test your water. If your water is 2 parts per million boron, then that can also be contributing to boron accumulation on the margins of the leaves. We don't believe at this time that the burn on the edges of the leaves is associated with sodium or chloride because of the plant's capacity for either sequestering or excluding those injurious salts as specific ions. Could you comment on the pros and cons of field budding versus nursery budding? Are there advantages in early trunk development in using flexible steel or fiberglass stakes? Another interesting comment, and this is one, again, that was, this concept of flexible stake was promoted by the arborist Brian Kemp, and he's exactly right. By having a flexible stake, there was an article written years ago in Science magazine, which showed that trees that were allowed to sway back and forth develop lignification and greater girth development than trees that were staked up the stake, staked securely to a rigid support, such as a wooden or heavy steel stake. So yes, you do wind up with greater trunk development. However, I'm hoping that the team led by Bruce Lampinen and the farm advisors, May and Elizabeth and Catherine, will all study and tell us whether or not the central leader trees that are being trained by the stakes, these small steel stakes, are actually greater in girth. And then pros and cons on field budding versus nursery budding. The biggest problem with nursery budding is there's not enough of those trees to go around. And you talk to the nursery people, you have to put an order in for pre-budded trees. If you want them for 2021, you would have had to put an order in March of 2020 because they're very costly to produce, and they're also harder to handle in the field. And again, we do not have a UC research project that has studied the canopy development of field budded trees versus pre-budded trees. nursery budded trees. So, but our experience is that that rootstock that is field budded, if properly handled, develops tremendous vigor, what I call horsepower in the springtime, because the rootstock has greater vigor or genetically driven growth potential than does the scion or the cultivar. So if you put the rootstock in early in the ground and farm it properly, it grows unencumbered by the dwarfing scion for a sufficient period of time, such that when you put the scion, the less vigorous scion bud in to the rootstock in mid-July, you now have a lot of horsepower that drives that scion into very vigorous growth, as much as an inch a day. So the value of planting pre-budded trees in most growers' minds is offset by the greater vigor that is imparted to the rootstock by growing it unencumbered by the cultivar until mid-July. Okay, 11, I appreciate your discussion on pruning. Is there a website where I can find more information on pruning? Well, we do have some videos, and you can find them online. They're not the best. Again, you can see I have the gift for gab, so we could talk about pruning on a video for an hour, and you'd probably be asleep when we got done. But let me just say this about pruning, and it goes back to an old statement that was made by Don Flaherty, who was an entomologist friend of mine when I first started as a farm advisor. And I called Don Flaherty and I was asking him about grape leafhopper in grapes. And about halfway through the conversation, he paused and he said, "Hey, Beatty, I know you're a young farm advisor, so I'm going to give you a piece of advice." I said, "What's that, Don?" He said, "You are never going to know anything about leafhoppers if you don't get your butt out in the field and go watch leafhoppers." And that's exactly the same thing with pruning. Go buy yourself a pair of pruning shears and get yourself a thermos full of coffee and go hang out with the pruners. Go find somebody who's pruning an orchard and go out there and watch what they're doing. And if you have your own orchard, prune with them and watch what kind of cuts they're making. And the contractor will spend time with you also and show you what you're doing. And by doing that, you will be a better horticulturalist, because that is what the University of California is holding these short courses for. We want you to have knowledge. Knowledge is power, and the better horticulturalist you are, the better capable you are of asking the kinds of good questions that make you a more successful farmer. Okay, 12, is central leader training the same as modified central leader? Yes, because the central leader, you started off as a central leader, and then quite honestly, the tree rapidly turns it into a modified central leader, which is, in my recollection of central leader system, the central leader and a modified central leader, the leader eventually becomes more or less a scaffold branch. And that is true with the trees that I've studied with, that's being done by Kemp and Hedrick in their system, that the tree does not maintain a true central leader like it would in a highly trained apple orchard, where you have physically held the central leader in the center of the tree, and now you have a wagon, several tiers of wagon wheeled limbs that are coming off the central leader. So it really is kind of a modified central leader. And the Australians have, they came to California and they saw what Brian and Jeb were doing, and then they went back, and they're very enthused about the modified central leader system. And the time will tell based on the research that's being done. Do we have any research comparing yield and limb breakage on pruned trees versus unpruned? My personal opinion, well, quick answer, no. Okay, why are we getting limb breakage in pistachio trees? Well, part of it is that the pruners are not all pomologists. And, you know, these guys are trying to make a living, and they're hippity hopping through these orchards. You've got thousands of acres to prune. So they're not studying every tree and making oftentimes the best decisions. Consequently, the limbs are oftentimes too crowded in the crotch. And as they get bigger in diameter over time, they're subject to breakage. Now, I know that Dr. Lampinen has felt that the vase-shaped system has produced an excessive amount of breakage, but in most of the orchards that I've seen, we don't suffer that amount of breakage. However, in his defense, this may be more common in the Golden Hills variety, and Craig has alerted us to the fact that we definitely need to space our primary scaffolds down the trunk as best we can. We don't want them all arising from the same spot, because that does in fact create a weaker crotch that is more prone to breakage in the Golden Hills variety.
Okay, so we have one more question and then we're gonna have to end. So if the last one, number 14, and then we'll have to wrap it up.
Okay, if you apply zinc to a 5-year-old tree, how long until the tree is dormant after the leaves fall off? I would just make a simple statement. A 5-year-old tree, you put the zinc on the 3rd week of October, and by the 15th of November, you have a tree that's in dormancy and accumulating chill.
Great, thank you. We're gonna wrap it up here. Thank you to our speakers. Thank you to Doug for moderating, and we will see you on Monday. Thank you, everyone.